is organized by three organizations. The first one is Romanian Agriculture and Forestry Science Academy, Gheorghe Ionescu-Șișești from Bucharest, Food Industry Section. The second is the Institute of Research and Development for Aquatic Ecology, Fishing and Aquaculture from Galați, Romania. And the third is Research and Development Station for Viticulture and Winemaking, Bujoru, Galați County, Romania. This conference is the theme of this conference is Challenge of Climate Change in Aquaculture and Agriculture. First presentation will be kept by the Anca Nicoleta Săvescu, and the name is Climate Change Adaptation through Ecological Management and Ecosystem Service, enchanted in experimental fish pond from the lower Danube region. Okay, one full.
Good morning, ladies and gentlemen. My name is Anca Nicoleta Săvescu, and it is a great pleasure to be here today and to have the opportunity to present our recent research entitled Climate Change Adapting through Ecological Management and Ecosystem Services Enhancement in Experimental Fish Ponds from the Lower Danube region. This study was carried out at the Research and Development Institute for Aquatic Ecology, Fisheries and Aquaculture in Galați, and explores how ecological management can increase the resilience of freshwater aquaculture systems under climate change. Climate change is currently one of the most significant challenges facing freshwater aquaculture worldwide. Increasing water temperature, prolonged droughts, altered precipitation regimes, and more frequent extreme weather events directly affect the ecological functioning of fish pond ecosystems. These changes reduce water quality and dissolve oxygen, promote excessive algal blooms, increase physiological stress in fish, and ultimately decrease aquaculture productivity. Therefore, developing adaptive ecological management strategies has become essential for maintaining resilient and sustainable freshwater aquaculture systems. The main objective of this study was to evaluate how ecological management practices can enhance the resilience of experimental fish ponds ecosystem under climate change conditions. Specifically, we assess the main climate-related pressure affecting freshwater aquaculture. Describe the ecological management measures implemented at the Bratish Experimental Agrofishery Research Laboratory. Also identify the main ecosystem services provided by these fish ponds, and also evaluated their role in supporting climate adaptation and sustainable aquaculture in the Lower Danube region. This study was conducted at the Bratish Experimental Agrofishery Research Laboratory, located in Galați country in the Lower Danube region of Romania. This research infrastructure provides ideal condition for experimental aquaculture studies and long-term environmental monitoring. The laboratory supports experimental fish production, environmental monitoring, and the development of sustainable management practices, making it an ideal platform for testing climate adaptation measures under real environmental conditions. This study followed an integrated methodological approach implemented at the Bratish Experimental Fishery Research Laboratory, and the research started with field observation to characterize the experimental fish ponds and identify the main climate-related pressures affecting the ecosystem. Environmental monitoring focused on key water quality parameters, including water temperature, dissolved oxygen, transparency, together with important ecosystem components such as aquatic vegetation, biodiversity, sediment characteristics, and water circulation. Based on this observation, adaptive ecological management measures were implemented and their effectiveness was evaluated. Ecological management considers the fish pond as an integrated ecosystem rather than focusing only on fish production. This research laboratory management includes environmental monitoring, habitat conservation, adaptive intervention, and sustainable use of natural resources. Together, these practices improve water quality, support biodiversity, and enhance ecosystem stability under changing climate conditions. You can see also a photo with our laboratory, a part of some fish ponds. Experimental fish ponds provide much more than fish production. They deliver important ecosystem services, including water purification, nutrient retention, biodiversity conservation, carbon sequestration, and local microclimate regulation. These services improve ecosystem functioning while supporting sustainable aquaculture. Our results show that ecological management improves the environmental performance of experimental fish ponds. Better water quality, biodiversity conservation, and adaptive management increase ecosystem stability and reduce the impact of climate-related stress. This finding support the use of ecological management as an effective nature-based solution for climate adaptation in freshwater aquaculture. This study demonstrates the strong link between ecological management, ecosystem services, and climate resilience. Healthy ecosystems support healthy aquaculture by maintaining environmental quality and reducing vulnerability for climate change. And strengthening ecosystem services is therefore essential for the long-term sustainability of freshwater aquaculture. In conclusion, our study demonstrates that ecological management is an effective approach for increasing the resilience of freshwater fish ponds ecosystems. And the research laboratory provides an excellent experimental platform for developing and testing nature-based solutions. And also, this approach can contribute to sustainable aquaculture while supporting long-term environmental protection and climate adaptation. Our research also opens several important perspectives for future studies. Future work should be focused on the integration of advancing monitoring technologies, including remote sensing, drones, artificial intelligence, and environmental sensors to improve ecosystem assessment. Another priority is the development of climate resilience indicators and the long-term evaluation of ecosystem services. Expanding ecological management practices at the region scale and integrated nature-based solution will further strengthen climate adaptation strategies for freshwater aquaculture. These developments will support both European climate objectives and the sustainable future of freshwater aquaculture. Thank you very much for your attention, and I hope this presentation has highlighted the importance of ecological management and ecosystem services. And if you have any question or if you want to discuss possible collaboration, You can see my contact on this slide. Thank you once again.
Thank you very much. Stop the share. Okay. If there are some questions, if not, we will go to the next one. Next one, it's Natalia Kulik from Białystok University of Technology, Poland, and it's your time now.
Okay, thank you. So good morning. My name is Natalia Kulik and I'm from Białystok University of Technology in Poland. And today I would like to show you climate change and the problem of drought in Poland. So let's focus first on the climate in Poland and temperature. The area average air temperature in Poland in 2024 was 10.9 Celsius and was as much as 2.2 Celsius higher than the long-term annual average. And when we will look for the atmospheric precipitation, the area average total atmospheric precipitation in Poland in 2024 was 607.8 millimeters, which accounted for nearly 99.4% of the normal value. But when we will look for a climate-water balance, during the growing season from May to October 2024, in most part of the country, evaporation from the ground accelerated precipitation. And this was especially visible in central and western Poland, where the climatic water balance values dropped even below 400 millimeters. And why is it so important? Because in Poland, we have extremely low freshwater resources. The amount of renewable freshwater resources per capita in Poland, based on the long-term annual average, is almost 1.6 thousand quadrometers, which increased a risk of water stress. And in nearly half of Euro countries, freshwater resources are very low, below 3,000 quadrometers per person. In Poland, Malta, Cyprus, and Czechia, they're below the level considered safe for water security. And in Poland, we have three main types of drought. First one is agricultural drought, happens when there is not enough moisture in the soil to support crops and natural vegetation. Another one is hydrological drought, occurring when water levels and water flow in rivers, lakes, and other surface water become much lower than usual. And the last one is hydrogeological drought. It's connected with a decrease in groundwater levels, which can reduce the amount of water available from people and ecosystems. And here we have a map with river water levels in Poland. And in 2025, the Vistula River, which is in Warsaw and in Krakow, it's the most important river in Poland. In Warsaw, it reached its lowest record level. On September 12th, the water gauge at the Warsaw Boulevard monitoring station showed only 4 centimeters, while the water flow was about 154 cubic meters per second. It was a new historical record. The previous record measured in 2024 was 20 centimeters. However, this measurement of 4 centimeters does not mean that the whole river was only 4 centimeters deep. It refers to a level measured in relation to a fixed point on the water gauge. And in some places, the river was still more than 2 meters deep. And how does it affect changes makes changes in forest communities? So the long drought, lower groundwater levels, and leave less water available in the soil. Older stands, especially those over 50 years old, have higher water demand, while the root systems regenerate less efficiently and may no longer reach declining groundwater resources. So as a result, trees take up less water, grow slowly, and their resistance decrease, what makes them weaker and more vulnerable to bark beetles attacks, which develop much faster under warm and dry conditions. And here I collect some examples what already happened in Poland. And the first one is from Białowieża forests. Compared to the period 2012-2021, a total decrease of 3,300 hectares was recorded in the area of dominant tree species. These include Norway spruce, European ash, downy beech. The greatest loss affected Norway spruce stands. And another one, what happened in Polish mountains Sudety. As a result of extreme drought in 2015, at the subconstituent bark beetles outbreak, 3.2 million quadrat meters of a dead spruce wood had to be removed. And of course, we are trying to do something with that, and we have some water retention programs, but they don't work really well. And I think it's because the society is still not really aware of how huge problem does we have. And as a proof, I would like to show you the comparison of Poland and Spain. So Spain retains approximately 40-45% of water, meaning it's able to store a much larger share of precipitation and river water in reservoirs and water management systems. And Poland retains only about 6.5% of average annual runoff. So most water quickly flows through river into the sea. And here we have a bibliography, and thank you for your attention.
Thank you very much. Stop the share. I have a question. I saw you say something about the decrease of level of water, and you changed the culture of crops in Poland, or what of this decrease?
Does we change what?
The culture. Crops, you have some crops, yeah? You change the structure of crops because you have less water.
Yes, we tried.
Yeah, you put first other kind of crops, good hybrids with less water, but you change also the structure. Now is not grain, it's something else.
No, I think it's mostly because of the climate change.
Yeah, this is the question. Okay, if are other questions. If not, we'll go to the next one. Thank you very much, Natania. Next one, it's from National Institute of Preventive and Social Medicine, Bangladesh, and University of Dhaka, Bangladesh, health-related quality of life and associated factor among climate introduced coastal migrants in Bangladesh, a cross-section study. Zarin Tasnim, it's online.
Good morning, distinguished chair, respected professors, fellow researchers, and honored guests. In Bangladesh, we have a well-known proverb, Nodi Bhange, Nodi Gore. In the beautiful language of our host country, Romanian, Reul distruge, iar Reul creează. Please forgive my attempt at Romanian pronunciation. And in English, it's translated to the river destroys and the river creates. For generations, this simple proverb has captured the essence of life in Bangladesh. A nation shaped by its rivers. Rivers have nourished our land, sustained our livelihoods, and defined our communities. Yet today, climate changes has transformed this timeless reality, forcing thousands of people to leave behind not only their homes, but also their livelihood, a social network, and sense of belonging. While migration may offer physical safety, it raises a critical public health question: health-related quality of life after they are displaced by climate change. Good evening again. Good morning again. I am Dr. Zarin Tasnim. It's my great honor to present our study entitled Health-Related Quality of Life Among Climate-Induced Coastal Migrants in Bangladesh. Thank you for your attention, and let's begin. Sorry for the interruption. I can't change the slides. To understand why this issue matters, let us first look at the climate realities faced by coastal Bangladesh. Bangladesh is recognized as one of the countries most vulnerable to climate change. Every year, millions of people experience cyclones, river erosion, storm surges, and salinity intrusion. These disasters destroy homes, agricultural land, and livelihood, forcing families to migrate. Unfortunately, many displaced families settle in riverine shore, which are themselves environmentally fragile. As a result, migration often become a transition from one vulnerability to another, rather than a pathway to safety. Climate change affects more than where people live. It also changes how they earn a living. Agriculture and aquaculture, which is fisheries, are backbone of coastal livelihoods. However, erosion and salinity permanently reduce cultivable land and affect fixed production. Consequently, many migrants lose the occupations they have practiced for their lives. Without stable employment, households experience reduced income, increasing food insecurity and long-term economic hardship. This creates a chain of events that ultimately affects health. The slide summarizes the pathway explored in our study. Climate hazards lead to livelihood loss. Livelihood loss drives forced migration. Migration then results in poor housing, unsafe water, reduced income, and limited healthcare access. Together, these factors influence health-related quality of life. With this background, let me tell about the research gap and objectives. Although climate-induced migration has been widely studied, most research has focused on economic losses and displacement patterns. However, limited evidence exists on the health-related quality of life of internal climate migrants, particularly in Bangladesh. To address this gap, our study had two objectives. First, to assess health-related quality of life across the 4 WHO QOL brief domains among climate-induced migrants in Subarnachal, Noakhali, Bangladesh. And second, to identify the demographic migration-related living condition and economic factors associated with their quality of life. Study in Subarnachal Upazila of Noakhali district. A multi-life was assessed using the validated Bangla version of WHO QOL brief questionnaire. Ethical approval was obtained and informed consent was received from every participant. River erosion was the leading cause of migration, followed by cyclones and salinity intrusion. Most participants migrated from Bola and Ras Lakshmipur district. One particularly important finding was that nearly two-thirds had experienced multiple displacement, illustrating that migration is often a repeated rather than a one-time event. Life after migration remained extremely difficult. Near 85% lived in fragile kacha houses, more than three-quarters dependent on saline tube well water, poor sanitation, inadequate healthcare, and reduced household income were most common. These conditions provide important context for understanding our finding. Migration also changed how people earned their living. Before migration, most participants were farmers or fishermen. After displacement, many lost access to land and fishing resources. Consequently, they shifted to insecure daily wage labor. Women were particularly disadvantaged, with most remaining in unpaid household work. To assess health-related quality of life, we used WHO QOL brief instrument, which measures 4 domains: physical health, psychological health, social relationship, and environmental health. Scores were transferred to a scale from 0 to 100. An overall score below 50 indicated poor health-related quality of life. Now, I would like to share the most important findings of our study. Our findings were striking. Nearly 89% of participants experienced poor overall health-related quality of life. Among the 4 domains, the environmental domain recorded the lowest score, highlighting challenges related to housing, water, sanitation, and access to services. The psychological domain was also considerably affected. After adjusting for potential confounding factors using multivariable logistic regression, we identified several significant predictors. Participants using saline water had almost 6 times higher odds of poor quality of life, making it the strongest predictor. Those experiencing multiple displacement had over 4 times higher odds. Women, individuals with without formal education, and participants whose income has decreased after migration were also significantly more likely to report poor quality of life. This finding suggests that environmental and socioeconomic disadvantages continue long after migration has occurred. These results have important implications for climate adaptation and public health. Climate-induced migration should not be viewed simply as relocation. Instead, it represents a combination of environmental, economic, and social challenges that continue to affect people's life. Repeated displacement, unsafe water, livelihood loss, and gender inequality interact to reduce health-related quality of life. This highlights the need for long-term support rather than short-term disaster relief alone. Our study has several strengths. We focused specifically on climate-induced migrants, used a validated measurement tool, and followed a standardized ethical procedures. However, because of the cross-sectional design, causal relationships cannot be established. Additionally, some information relied on participants' self-report, introducing the possibility of recall bias. Finally, let me conclude. In conclusion, almost 9 out of every 10 climate-induced migrants experience poor health-related quality of life. Environmental condition, particularly saline water, together with repeated displacement, reduced income, and lower educational status, was major determinants. Our findings emphasize that climate adaptation should extend beyond infrastructure. Policies should integrate safe water, secure housing, livelihood restoration, land protection, and accessible mental health services to improve the well-being of displaced population. Thank you very much for your kind attention. It has been a privilege to share our work with you today.
I understand the issue of this climate change in Bangladesh and the impact, the big impact of the people. I hope someone can, especially the government, can get some measure to resolve this one. Yes, we have a question from Roger. Yeah, Roger.
Thank you. Thank you, Ms. Zarin, for that wonderful presentation from Bangladesh. I am just surprised that 89% of the climate-induced migrants really are affected by climate change in Bangladesh. I just wonder, because you have some actionable measures there. At this point, what is the government of Bangladesh doing? I mean, what is in place? Because you've already discussed what has to be done. I just wonder what is currently in place in terms of policies, in terms of infrastructure we have in Bangladesh.
And Bangladesh government is trying to do some NGO works like increasing the awareness, health promotion, and health campaigns and then some NGO works to support them, the women's, the people to support who have been migrated to help them and budget. They have implemented some works to relocate them. And many other works are in processing to improve the health related quality of lives of the migrants.
So basic, we'll start with the clean water. No, this is the basic.
Yes, this awareness is very important because they are not aware of the clean water and sanitation very much, and they are don't have lack of accessibility to health, and they can't afford because of their poor economical status. So government is trying to do, and NGOs of our country is trying to do to help them.
Okay, thank you very much. We saw a little bit more than what you present in the original paper. You give some details. Thank you very much for your presence and for this paper. We'll go to the next one if are not other questions. No, are not. Okay, the next presentation is Diminish livelihood in the coast, the impact of climate change on small-scale marine fishery in Bangladesh. It's a number of people from Southeast University from Dhaka. If someone are online to present the paper.
Yes, it's us. Hello. Good
Hello.
morning. I will share my slides now. Okay, I will start. Thank you. And good morning, everyone. I'm Jeba Fauzia Munia, lecturer at the Department of Architecture, Southeast University, Bangladesh. It's a privilege presenting at the Climate Change Conference today. So before I begin, I would like to acknowledge and sincerely thank my co-authors, Syed Munirul Islam, Masudur Rashid, Abdullah Alamin, and Shahriar Alam Shanto. So let's get right into it. So let us begin with the introduction. So our research titled The Diminishing Livelihoods in the Coasts, the Impact of Climate Change on Small-Scale Marine Fishers in Bangladesh, explores the livelihoods of coastal small-scale fishers who contribute over 90% of Bangladesh's marine fish supply and are a critically marginalized community facing a vicious cycle of poverty. Despite their cultural and nutritional significance, they endure systemic deprivation exacerbated by climate change, including cyclones, salinity intrusion, and dwindling fish stocks. So by fostering capacity building and creating alternative economic opportunities, the research aims to mitigate climate-induced vulnerabilities improve living conditions, and provide a pathway for coastal fishing communities to achieve long-term socioeconomic stability. So there are three core objectives of our research. The first being characterizing the lifestyle and livelihood patterns of coastal small-scale fishing communities. The second objective was to identify the drivers of socioeconomic and climate-induced vulnerability among these populations, and finally, to formulate policy-level interventions and special solutions for building climate-resilient fishing settlements. For the methodology, as you can see in the screen, the research followed three sequential phases. The first phase was baseline and literature review, where socioeconomic conditions and baseline vulnerabilities were evaluated using Bangladesh Bureau of Statistics data and architectural vulnerability sketches. Phase 2 was case selection protocol. Here we conducted walking reconnaissance audits across 7 villages and finalizing 4 representative study sites based on proximity, climate exposure, and socio-economic factors. And the last phase was field survey and verification, where we validated demographic data and evaluated housing conditions using surveys, FGDs, semi-structured questionnaires, and on-site audits. Moving to our next section, let's examine the context of the coastal small-scale fishermen and their critical role in the sector. Bangladesh is defined by its deltaic foundation, a vast network of 24,000 kilometers of rivers and over 200 active waterways. This ecosystem is not only essential for national nutrition, it supports a massive rural working class and stands as the second most valuable agricultural sector in the country. However, we have observed a significant habitat shift between 2003 and 2014. Natural open capture fish habitats have declined by 0.16 million hectares, while closed culture fishery habitats have expanded by 0.35 million hectares, driven largely by market demands. So to understand the scale of these communities, we look at historic geographic mapping. Data from the FAO in the late 60s identified 706 marine villages with 51% situated in Chittagong, which accounted for 72% of all the coastal fisher households at the time. And then by 1991, a comprehensive survey by the NGO Codec mapped the growth of these communities to 1,350 coastal fishing villages across our key districts, which you can see from the chart presented at the lower left corner of the slide. Now, turning to the livelihoods of these communities, we must address the vicious cycle of vulnerability. Our region benefits from high marine fertility in the Bengal Delta, where warm coastal zones and nutrient-laden silts support 32,000 square kilometers of the bay. Yet, rising temperatures and excessive salinity intrusion are now causing coastal fish stocks to contract. This is compounded by systemic shocks. Fishers face environmental volatility from increasing natural calamities, alongside a lack of essential inputs such as insufficient gear, restricted access to fish harbors, and a complete absence of financial support. Furthermore, institutional seasonal bans now limit their traditional ancestral harvests. This results in a climate poverty trap. Vulnerability is tied to landlessness. While landed fishers can diversify into agriculture, the landless lack investment capital. Geographically isolated, they remain excluded from developmental aid. So building on our methodology, we move to the selection of our study sites. So to conduct a robust comparative analysis, this research employs a comparative approach to examine the diverse livelihoods and attributes of fishers across 4 distinct villages. So we selected 4 specific sites for our primary analysis. Village 1 is Futubiapara at Cox's Bazar. Village 2 is Ahmedia Kata in Moheshkhali. Village 3 is the Dakshin Kolabhattapara fishing village in Chittagong. And Village 4, which served as our primary selection site, is Delipara at North Selimpur, which is a marine fishing village located in Sitakunda Upazila. under the Chattogram district. So this selection was finalized by rigorously applying our methodological criteria to ensure these sites represent the broadest spectrum of coastal fishing life. Focusing on our primary site, Delipara, we see a village defined by its direct proximity to the Bay of Bengal, as you can see in the picture presented in the slide. Protected by a coastal embankment, the settlement lies immediately to the east. Its layout is highly dense, with houses clustered into a single compact block. The surrounding context highlights the community's complex reality, a blend of natural features like green belts and mangrove forests juxtaposed with industrial elements like the nearby shipbreaking yard, and the essential presence of traditional fishing boats. This spatial configuration is fundamental to analyzing the site's unique vulnerabilities and settlement patterns. Moving to the challenges faced in Delipara, we observed three primary drivers of struggle for these small-scale fishermen. First, declining stocks. While marine catches have seen increases, the reality is overfishing by large commercial trawlers, coupled with water pollution and broader changes in the natural environment, are depleting resources for our local community. Then there comes seasonality. The fishers face extreme exposure to seasonal limitations. They have only 4 months of prime fishing. For the next 5 months, they catch primarily Bombay duck and limited estuarine species. Furthermore, from mid-April to mid-July, fishing in the sea becomes impossible. Finally, natural shocks. Due to its proximity to the Bay of Bengal, as mentioned earlier, Delipara is severely impacted by cyclones, tidal flooding, coastal erosion, and salinity intrusion. Cyclones are the most hostile threats. The catastrophic devastation of the 1991 event remains a stark reminder of the extreme vulnerability of this location. Our analysis of the struggles in Delipara continues with 3 further critical threats. The first one is piracy, which has increased rapidly due to illegal foreign trawlers seizing catches at sea and criminal attacks occurring on shore. And then there comes land loss. So severe sea erosion threatens the Chittagong coastal belt, and existing embankments and afforestation are failing due to poor maintenance and improper utilization, rendering them unable to withstand high tide currents. And then comes environmental degradation. So proximity to industrial zones and shipbreaking yards poses a constant threat. The final challenges in Delipara highlight deep-rooted socio-economical barriers, which I'm going to explain now. So the housing condition is really poor. Structures are fragile and they reflect extreme poverty, as you can see in the pictures. A single small room is typically shared by 4 to 5 people, and the congested layout leaves almost no provision for natural light or ventilation. And then there is poor marketing system. The market is controlled by external actors. Fishers cannot set their own prices and will remain disempowered until they establish independent market control. Lastly, the lack of credit and insurance. To be precise, there are no formal savings or credit facilities, forcing reliance on local moneylenders, which in our native language call arotars or dadundars. Furthermore, there is no insurance policy for fishers or their trawlers, leaving them without any financial security against loss. So to synthesize, we categorize the vulnerability of coastal fishers into 3 dimensions: environmental, physical, and social. High ecological dependency on unpredictable conditions, increased climatic shocks, and resource depletion create long-term livelihood insecurity. And then tangible destruction of productive assets, such as boats, nets, etc., pose constant risks to fishers' lives and safety. Also, poverty vulnerability cycle traps households lacking resources for disaster recovery. And also there is a systematic skill gap and no institutional support. We now turn to adaptability and coping capability, focusing on building a resilient fishing community through some measures. which are disaster resilient habitat, DRH. So we propose integrating land use planning with coastal mangrove afforestation, semi-hard embankments, and strategic plantations to physically resist cyclone hazards. And then there is resilient housing. Our design strategy includes optimizing layout, orientation, and compact homestead arrangements. We propose two-storied nucleus houses, as you can see in the diagrams demonstrated in the slide, using preservative-treated local materials like bamboo, wood, steel, and concrete to ensure structural integrity. And then we propose integrated livelihoods. We identify the scope for alternative supplemental livelihood activities by integrating these livelihood models directly into housing and settlement design. We create a system where the physical habitat itself supports increased income, moving beyond mere survival towards long-term economic stability. To enhance adaptability, we must move beyond traditional fishing toward livelihood diversification. Our proposed strategies include saline-tolerant aquaculture. So we recommend fast-growing short-cycle species such as monosex tilapia, silver barb, and prawns. What happens is these species tolerate varying salinity levels and allow for harvest within 4 to 6 months. And then we propose homestead level production. So we are exploring the potential for dry fish processing along with crab and kuchia, which is the mud eel fattening, which can be managed directly at the household level, and it has pretty low maintenance process. And then integrated farming systems. To maximize land use, we propose parallel crab and shrimp farming along embankments, polyculture of carps and prawns, and integrated systems combining fish with vegetables or poultry. So these adaptive measures transform the settlement from a site of vulnerability into an active, productive landscape that supports resilient economic growth for the fishing community. To further diversify income, we integrate livestock and agriculture. First, we promote household-level poultry and goat rearing, providing a vital, stable secondary income resource that particularly empowers women. Also, we emphasize resilient practices, including saline-tolerant rice cultivation and intensive homestead vegetable gardening. We also suggest community-based farming, introducing rare or unseasonal crops, and developing mixed fruits and herbal plantations. We believe these initiatives reduce the community's singular dependence on marine resources, establishing a stable year-round economic base resilient to seasonal shifts and saltwater intrusion. Finally, we turn to non-farm income and integrated homestead farming to complete our resilience strategy. So we propose home-based enterprise. We encourage diversifying into agro and fish processing, such as producing pickles and dry fish. We also support cottage industries, including handicrafts, kaka stitching, and bamboo furniture making, alongside small business ventures like tailoring shops, restaurants, and grocery stores. Integrated homestead farming model has 3 core objectives: optimizing land use for sustainable production, improving the nutritional security of the family, and increasing household income, while specifically fostering women's empowerment. By integrating these productive activities directly into the domestic space, we create a holistic environment that secures both the livelihood and the future of the fishing community. So we conclude with the design of a disaster-resilient settlement structured to enhance safety and community cohesion. The settlement is organized into 16 clusters, as you can see in the pictures, totaling 94 homesteads. Each cluster features 5 to 6 homes grouped around a central courtyard, oriented along a linear spine road, and critical infrastructure, including a cyclone shelter, school, and market, is located at the heart of the settlement for easy access. And then we emphasize on resilience and sustainability. The layout also integrates ponds, communal garden spaces, and extensive plantations for both protection and supplemental income. Each cluster is also equipped with a dedicated biogas project. And then we also emphasize social connectivity. To foster cultural interaction, the plan includes a temple and a playground, ensuring the settlement remains a vibrant, well-connected community. So we have come to the conclusion now. So this research addresses the precarious reality of Bangladesh's small-scale coastal fishers, a community trapped in a cycle of climate-driven dispossession and socio-economic marginalization. While these fishers are vital to our blue economy, they remain vulnerable to the compounding effects of cyclones, erosion, and systemic exploitation. Our study proposes a transition from mere survival to resilience. We have developed a multi-dimensional framework that integrates livelihood diversification, disaster-resilient habitats, and holistic development. Ultimately, this work is about more than just infrastructure. It is about honoring the incredible cultural endurance of a community that continues to dream and create in the face of constant destruction. By aligning our design strategies with the socioeconomic realities of the coast, we can transform these villages into productive, empowered, and truly resilient habitats. Thank you very much for listening. I would be happy to answer any questions that you might have about the research. Thank you.
Thank you very much, Juba. If there are questions, okay, the first, Roger.
Thank you very much, Ms. Jeba. I'm truly impressed with your study. It's very comprehensive, and I particularly like your multi-dimensional disaster resilience strategy. I just wonder, because we almost have the same problems here in the coastal communities in the Philippines. I just wonder, what do you think are the challenges that you might encounter given the socioeconomic situation in Bangladesh, the political situation? What do you think are the specific challenges that we have to hurdle in implementing that sound resilience management plan?
I think the first challenge that we might face if we ever take the initiative to implement the planning or like the planning for making the community resilient is I think people from multiple fields has to come together to implement the plan. For example, you cannot rely on the policy making alone to make a resilient community. The planners and architects has to play a big role in, suggesting what might work for them or what might not work for them. And also, according to your question, if I want to answer the socioeconomic aspect, since ours is a lower income country, in that case, I think the general people, especially the middle class people, they are not even being able to ensure their the provision of their daily necessities. And the community that we are talking about, they're marginalized because of this reason. So I think it's gonna be a long way to put our national focus towards these marginalized people. But I think it's a good start that the policymakers, the planners and architects are starting to think about it. I think it's a good start that the light is being shed on the livelihoods and their sufferings, because it goes beyond economic sufferings, right? So I think these are the challenges we might face, but I am hopeful that if all the multidisciplinary expertise comes together, there might be a solution one day. Yes, thank you.
Thank you very much. Mihai, I saw you have other question.
Hello, good morning to everyone.
Hello.
First of all, I would like to congratulate you on your presentation. It was
Thank you.
very
Thank you for
detailed,
listening.
and it managed to form a complete picture regarding this social economical struggle, the social economical struggles of this particular population. A question for you is, does the university have any leverage towards the policymakers? And if so, can you suggest to the policymakers some subsidies for these populations? Because as I saw your presentation, you underline the fact that this is a very vulnerable population, and not only climate change is impacting their livelihood, but also there are social factors, as you say, piracy and heavy industry near their natural habitat and their livelihood. So maybe can you influence the policymakers? Because when you are talking, you said that this initiative highlighted in your study needs a couple of experts and to be involved in changing their habitat and the way they are living and their living conditions and their view on how they need to live. Do you have any leverage? Can you access the policymakers there in Bangladesh? Thank you very much.
Thank you for your question. I think it is possible because you know, in university level, when we are giving projects to our students, we always try to give them challenges that, you know, that's gonna create a relationship between them and the marginalized population. Most of our projects, we try to integrate those people because you know what happens with urban development is we're only focusing on the capital cities, like how we can improve more. But there are many marginalized people, especially in our country. There are farmers. We have the fishermen, the what we were talking about earlier in our research. So I think influencing policymaking through the university is a very feasible step because when we give our students some project, we send them to conduct some survey. And there has also been some initiatives to, you know, after they bring the survey materials to, you know, make the people aware of the fact that these people exist and what they're facing, we can do workshops. And by that, we can, you know, the layperson has to be made aware before we can reach the policymakers. So when the laypersons are made aware, I think it is very much possible to influence them to bring some light onto the topic. And yeah, I think it's very much possible because what happens with our architectural works is that we don't believe in keeping it to ourselves. We try to showing it to the people, and we always try to show it in a way that even the people that do not have any expertise on the matter, they can relate with it. So this is one of the core challenges we face when we're like doing any projects or we are interacting with any community. So yes, I think it's a very possible process. It might take longer than we might think it should take, but yes, it's possible, and we hope it takes shorter than we estimate. Yeah,
So
because everyone
from
matter.
yeah, so
Mhm.
from what I understand, this project is in its early stages, but the good thing,
Mhm.
as you said, is the fact that you are shining a light on this population, which is very
Exactly.
susceptible to climate change and the very numerous social factors. Yeah,
Yes, of
great
course.
presentation. Thank you very much for
Thank you.
your answer.
Thank you for your question.
Bye-bye.
Thank you, Sheba. I want also to
Thank
thank you
you.
to use our logo in your presentation. We don't give that, but you by himself make that, and I want to thank you to use it. And I have here
Thank you.
another colleague, Yunus, who have another question. Please.
Yep,
Hello,
sure.
Jeba. Hello, my name
Hello.
is Marco Ionuț. I am working here to the institute. Congratulations for your presentation. It's very
Thank you for
interesting.
listening. Thank you.
Given the high level of fish consumption in your country, there it's existing the institute to stock the waters with fish. You exist the some institute or some company to creating the little fish and diverse in the water for next period to next future, or because the stock of the fish has a limited
Yep, of course. It's depleting every day.
yeah, and
Mhm.
in your country, it's some institute to stock the waters, with fish.
There are some government initiatives. For example, the coastal fishermen, they cannot fish all the year round. There is a fishing ban for like 8 months approximately.
Yeah.
So the fishermen can only fish for 4 months because during the remaining 8 months, it's the breeding season for the fishes. So if they keep catching the fishes that hasn't like bred, it's gonna deplete faster than it should, right? So the government enforces this very strongly that the fishermen cannot fish during those seasons. And this is one of the reasons why they're suffering because they don't have any alternative economical support. Like the only thing they know how to do for generations is fishing. So yeah, this is, I think in our country, it's a very strong regulation when it comes to protecting the ecosystem in the
Yeah,
waters, especially the marine waters.
it's important to protect it for
Yes.
Okay, thank you.
Thank you for your question.
Thank you very much. So we understand you have some program to populate the area with fish, and you have also some time when the fish is prohibited to be fished.
Yeah.
Okay, so
Exactly.
it's a little bit more like in European policy because we have something similar. Some period of time it's forbidden some species to be fished, and some other time we can catch it. So to give a little bit to the to the this living to reproduce, to grow, to have a little bit time to breathe. Because
Yeah, of course.
if you catch 24 hours for 24 hours, it will be no fish in the future. And this is the idea to be also in the future. Okay, thank you very much. Was very interesting. As you can see, a lot of people ask you about a lot of things because it's interesting. And I have only one question about the cluster you put in your example. You says about some clusters. Do you have only one to already in place, or will be in the future?
Are you asking if it has been built or not?
Yeah.
Like, it hasn't been, like, there has been some initiatives to do some pilot projects, not particularly for the fishermen, but for the marginalized communities. But no, not specifically for the fishermen. From my knowledge, there hasn't been any projects that has been implemented in a master plan level. So it's still on the planning and policy making phase at this point.
Okay,
In the future, maybe.
You give the idea. Now it's the politician to need to change some rules, and after that will be probably some money to go on the field to make this kind of stuff, because also high level of water it's other issue, and so on. So you have many problems there, and this population have many problems, and
and I
sometimes
would
we
also
need
like
help.
to I would also like to add that most of the initiatives that has been taken, it's to relocate them, but what we're trying to do is to keep them in their place and ensure safety and resilience. So it needs deep research, and it needs the to relate to their daily sufferings in a more deeper level. So I think one day for sure.
Also, I think the relocate is not a good policy.
No, of course not.
Okay, thank you very much, and
Thank you.
it was a pleasure to be with us with your presentation. We will go
Thank
to
you.
the next one now.
Thank you so much.
Next one come from Philippines, and it's climate justice and food security in Anthropocene. That will be very interesting.
Thank you. Good morning, everyone. It is our honor with John Flor Macluwi S. Oliero. I am John Christopher de la Cruz. We are from National University, Philippines. And it's our honor to present to you our study entitled Climate Justice and Food Security in the Anthropocene. For the abstract, climate change has become one of the greatest threats to the global food security, disrupting agriculture and aquaculture while increasing the vulnerability of millions of people worldwide. Although existing responses often emphasize technological innovation and climate adaptation, this paper argues that food insecurity in the Anthropocene is fundamentally a problem of climate justice. Demonstrate that those who contribute least to the climate change, particularly vulnerable farming and fishing communities, bear its greatest burdens. Drawing on climate justice and Russian political philosophy, the paper proposes a justice-centered framework that emphasizes fairness in the distribution of climate risk responsibilities and adaptive capabilities. Finally, it argues that sustainable food system cannot be achieved through technological solution alone, but required institution grounded in justice, equity, and the protection of the least advantaged. For the preliminaries, climate change has emerged as one of the defining challenges of the 21st century, reshaping not only natural ecosystem, but also the social, economic, and political foundation of human societies, while posing unprecedented threats to global food security. Rising temperatures, extreme weather events, sea level rise, and changing precipitation pattern continue to disrupt agriculture and aquaculture, undermining food production, livelihood, and the long-term resilience of communities. Food security extends beyond the ability of food. It also requires equitable access, fair distribution, nutritional adequacy, and the capacity of individuals and communities to sustain their well-being over time. Existing responses have largely emphasized technological innovation, climate adaptation, and increased productivity. While essential, these approaches often frame food insecurity as a technical problem that can be solved primarily through scientific and managerial solutions. Such perspective overlooks a more fundamental philosophical question. Why those who contribute least to the climate change consistently bear the greatest burden? This question shifts the discussion from environmental management to political philosophy, where issues of responsibility, fairness, and distributed justice become central to understanding climate change and its consequences. The Anthropocene further reinforces this perspective by recognizing that environmental change is largely anthropogenic, making climate impact matters of moral and political responsibility rather than merely unfortunate natural events. Climate change therefore exposes deep inequalities in the distribution of environmental risk, economic opportunities, and adaptive capacities, leaving vulnerable communities disproportionately affected despite their minimal contribution to historical greenhouse gas emission. Food security should consequently be understood not only as the result of ecological disruption, but also as the outcome of political, economic, and institutional arrangements that shape vulnerability and determine who bears the cost of the climate change. This paper argues that food insecurity in the Anthropocene is fundamentally a problem of distributive justice, requiring a normative framework grounded in a climate justice to ensure that the burdens of climate change are no longer borne by those least responsible for creating the crisis. Now, for the climate change as a problem of distributed justice. Climate change is commonly understood as an environmental crisis. However, its most profound consequences arise not simply from environmental degradation, but from the unequal distribution of its burden across societies and generations. From the perspective of political philosophy, the central question is not merely how climate change occurs, but whether its risks, responsibilities, and consequences are distributed in ways that satisfy the demand of justice. Climate change creates a moral asymmetry by allowing those who have contributed least to the global greenhouse gas emission to bear the greatest social, economic, and environmental costs, thereby separating responsibility from burden. This distributed injustice cannot be explained solely by geographic or natural variability. Rather, it is mandated by political, institution, economic, structure, and unequal access to resources that shape vulnerability and resilience. Existing responses frequently emphasize technological innovation, economic efficiency, and climate adaptation. Yet, they often neglect the more fundamental question of how climate burdens, responsibilities, and adaptive capacities ought to be distributed. The key issue is not that climate change affects everyone, but it affects people unequally despite an equal contribution to the problem. Climate justice therefore reframes climate change as an issue of moral responsibility by asking who should bear the cost of mitigation, adaptation, and recovery, and compensation for climate-induced harms. Historical immersion further strengthened this claim. As an industrial nation, accumulated economic prosperity through development pathways that contributed disproportionately to the climate crisis, giving rise to differently moral obligation. Because climate change is anthropologic, its consequences cannot be regarded as morally neutral event. They generate obligation of accountability, institutional protection, and distributive fairness for both present and future generations. Climate governance should therefore be evaluated not only by its effectiveness in reducing immersion, but also by its capacity to distribute climate risk, resources, and adapted opportunity according to the principle of justice. Climate change is fundamentally a problem of distributed justice because it determines who benefits from development and who bears its environmental costs. Recognizing this injustice provides the normative foundation for understanding food insecurity as its most visible manifestation. Now, onto the food insecurity as the manifestation of climate injustice. If climate change constitutes a distributive injustice, then food insecurity is where that injustice becomes most visible, revealing how an equal climate burden translates into unequal life opportunities. Food insecurity should not be understood merely as a problem of inadequate food production, but as an equal distribution of food, resources, and adapted capacities that determine who is able to secure a dignified and sustainable livelihood. Climate change transforms environmental hazard into humanitarian crisis because political, economic, and institutional inequalities determine who can withstand climate shocks and who is left most vulnerable to their consequences. Vulnerability is therefore socially and institutionally produced rather than naturally determined, arising from unequal access to land, technology, infrastructure, financial resources, and effective public institutions. Small-scale farmers, fishers, and rural communities bear disproportionate burdens because climate-induced crop failures, declining fish stock, prolonged drought, and extreme weather events threaten not only food production, but also livelihood, income, and long-term community resilience. Food security becomes the most visible outcomes of climate injustice because unequal environmental impact translates into unequal access to food and livelihood. Hunger, therefore, represents more than biological deprivation. It reflects unequal access to the materials and institutional conditions necessary for individuals and communities to live with dignity, security, and human flourishing. Developing countries experience greater food insecurity, not because of inherent limitation, but because historical pattern of economic development have produced unequal capacities to anticipate, respond, and to recover from climate-related risks. Viewing food insecurities only through the lens of productivity obscures a more fundamental reality. Hunger often results not from absolute food scarcity, but from an equal system of distribution, political and prioritization, and institutional failure. Addressing food insecurity, therefore, requires more than increasing agricultural output. It demands transforming the social and political institution that reproduce vulnerability while ensuring that climate governance prioritizes justice over charity. Food insecurity is the distributed manifestation of climate injustice because it reveals how unequal institution determine who eats, who survives, and who bears the greatest cost of changing climate. Recognizing this injustice necessitates a normative framework for distributing climate burdens and responsibility, to which Russian political philosophy now turns. Towards a Russian frameworks for climate justice and food security. Recognizing food insecurity as the distributed manifestation of climate injustice required a normative frameworks capable of determining how climate burdens, benefit, and adaptive capacity ought to be distributed. Although Rawls did not explicitly address the climate change, his theory of justice provides a compelling philosophical framework for evaluating whether climate institutions are fair, legitimate, and morally justifiable. Rawls' veil of ignorance requires that principle of justice be chosen without knowledge of one's social position, economic status, or geographic location applied to climate change. Rational individuals would reject institutions that expose certain population to chronic food insecurity simply because they live in a climate vulnerable region. In Rawls' first principle of justice, affirms that equal moral worth of every individual, implying that all person possesses an equal claim to the basic condition necessary for survival, including secure access to adequate food. Food security should therefore be regarded as a primary social good, since without it, individuals cannot meaningfully exercise their liberties or pursue their conception of the good life. Roles difference principle requires that social and economic inequalities be arranged to benefit the least advantaged. Apply to the climate governance. This means prioritizing climate vulnerable communities in adaptation funding, technological innovation, and food security policies rather than maximizing aggregate economic efficiency. Ross's conception of the basic structure of society further requires that institutions governing agriculture, food system, environmental policy, and international cooperation distributed climate risk, responsibility, and opportunity according to principle of justice. A Russian framework, therefore, rejects climate policy that improve overall welfare while leaving vulnerable communities trapped in persistent food insecurity, emphasizing equitable institutions that recognize historical responsibility, economic capability, and climate vulnerability. Climate adaptation should be understood not merely as humanitarian assistance, but as a fulfillment of moral duties arising from distributive justice, ensuring that sustainable food systems protect the least advantaged rather than simply maximize production or economic growth. A Russian framework ultimately transformed food security from a technical objective into a question of institutional justice, demonstrating that climate justice is not an alternative to food security, but the normative foundation upon which just, sustainable, and resilient food system must be. Now, for the concluding reflection, climate change compels us to rethink justice because it has fundamentally altered the relationship between responsibility, vulnerability, and well-being. The Anthropocene demonstrates that environmental crises are no longer merely ecological events, but the consequences of collective human decision that generate moral and political obligation. If food insecurity reflects the unequal distribution of climate burdens, then hunger should be understood not as an inevitable outcome for the nature, but as an evidence of institutional injustice. The pursuit of food insecurity, therefore, cannot be separated from the pursuit of justice because sustainable food system depends as much on fair institution as they do on specific and technological innovation. A Russian perspective reminds us that the legitimacy of the climate institution is measured not by how efficiently they promote economic growth, but by how effectively they protect the least advantaged member of the society. Climate change, again, reminds us that our future is shared. Every decision we make today will determine whether the future generation inherit a world of hope or a world of hardship. Justice consequently becomes the precondition for sustainability rather than its consequence, since environmental resilience cannot be achieved while structural inequalities remain unaddressed. The Anthropocene challenges humanity not only to transform its relationship with nature, but also to transform the institution through which environmental risk and opportunity are distributed. The success of future climate governance will therefore be judged less by the quantity of the food societies produce than by whether all people are able to access food with dignity, security, and fairness. Climate justice is not simply one dimension of food security. It is the moral foundation that gives food security its legitimacy and meaning. If the defining question of the 20th century was how to produce enough food, then the defining question on the Anthropocene is how to distribute its benefits and burden justly. Again, climate change is not merely an environmental crisis, but a moral political one. By viewing food insecurity through lens of Russian philosophy, we are reminded that the true sustainability is achieved only when the most vulnerable are protected and no one is left behind. Because justice or climate justice is not simply about saving the planet. It is about protecting humanity itself. Thank you, everyone. And that's our study, Climate Justice and Food Security in the Anthropocene.
Thank you very much.
I'll go first. Yeah, thank you very much for your presentation. So it was very complex. And the question is, how do we apply the things that you are hypothesizing about in your presentation? Because the concept is very good. The presentation was very good. And I think that it addresses a global audience. But as before, I'm not trying to be the bad guy here, but I think I was asking you if you have an idea how to influence the policymakers and the decision factors maybe in your country, so we have some ideas, because the theme of the research and the presentation is very interesting. The fact that there is climate justice, and the facts that you are talking about are very, very complex and very sincerely very emotional I think for everyone present here. And just wanted to ask you, do you have any idea how to influence and how to apply the things that you are talking about in your presentation? Thank you very much.
Probably people are doing it. A vulgar presentation in joining several groups, especially when it comes with the decision making with the policy. Here in our country, some of the policy have the public talk, wherein the policymaker asking comments and asking some of the, for example, some of the farmers what they can do to help them. Now, as I said in our presentation, some of the especially farmers, in our country, we have high heat climate change totally. Now, at first, back then, we are one of the most produced rice in Asia. But now we suffered because of the climate change. We suffered the least production of the rice. Aside from being available or vulgar in stating the problem and encouraging the policy, joining the different group. Probably I can suggest, or I can still suggest with the local government through groups to implement strictly implement those laws and those regulations that we have. Technically we have regulation and policies already, but one of the problem is some of that policies not strictly implemented. So one of the maybe hopefully by joining different groups or by verbally telling the statement or sharing the statement of what we are fighting for is probably somehow sometimes they change and they make a policy that everyone fairly benefit.
Okay, thank you. Basic, you said something like that. They need to step up to give to the local government and national government the idea what is happened, and in some way to be help at this person through the agriculture policy. This is the issue.
Yes.
Yeah, we have something like that in Europe for many years. Don't work well. So.
Yes.
And now in Romania, now we have also a war at our border, Ukraine, Russia. So we have another problems. So
we have a problem about the water system here, like in the farmer, because of the heat. The government has the project of the water system in every farming area, but the problem is sad to say some of the projects are not continuous or totally not happened. So it's not totally happened. The budget, as you know, is not given to the people who should benefit, something like that.
yeah, but also, for example, here we have many years around. I think the last 5 years, what dry, and
Yes.
it's very hard to go to use and or to keep the farm working. You change the new hybrid, you change everything, but it's the change of climate are so big and so fast, and all this small change you make it cannot keep the farm flow, and it's a very big problems, especially if the farm is small. And this is the big problem with the small farm, not with the big farms who have political connection, and
Yes.
they have possibility to get more money from the production, to packing, to make something food or something like that. No, we discuss here about small farming, and the small farming it's very hard hit in with the climate change, and I think this is globally, not in only one country. I think it's globally, and we don't know what will be in the future, because this small farm basic keep running the old agriculture sector, and all this supermarket and everything come from these small people who don't have a big income. And this is the basic policy of agriculture in the world. It's not good balance, and I think this need to be changed, but it's very hard. And your paper, it's in this direction to to change.
Yes.
Okay, thank you very much. And we will go to the next one. Thank you to
Thank
be
you.
with us, and will be more interesting. You will see. The next presentation, it's local climate action initiative in Philippine municipality, a case study from Misamis University, if someone is online. April, okay. Share, perfect. Full screen.
Hello, mabuhay. Can you see the slides?
Yeah.
And am I audible? Okay,
Yeah,
thank you very
perfectly.
much.
You can start your presentation.
Hello, once again, my name is April Farrell Ermelacion, and on behalf of my co-researcher Bonifileo Olubay, it's my honor to present our study titled Local Climate Action Initiatives in a Municipality, a case study. Climate action is globally urgent as planetary limits strain ecosystems and societies. In the Philippines, however, climate strategies remain hindered by governance and institutional gaps at the local government unit level, weakening local implementation of the national commitment. And while some research examines how certain local adopt climate measures, local level evidence, especially from rural and understudied areas like Mindanao, which is an island in the southern part of the Philippines, remains limited. Studies also show that meaningful climate governance requires lived experiences and community perspectives that are often missing from formal policy processes. So this study addresses that gap by providing a qualitative, people-centered case analysis of how climate action is experienced in the municipality. It contributes by linking national goals with community realities, offering insights valuable to policymakers, LGU officials, researchers, and local stakeholders working to improve climate resilience. So these are some of the theories that we use. We have the institutional theory, social ecological systems, and the advocacy framework. And our study was able to derive 5 themes. We have the multi-level climate governance and even community participation, urgent climate action by lived experiences, structural and resource gaps, and the shared responsibility for sustainability. So here's the objective of our study. So the study explored the local climate, in one of the municipalities of Misamis Occidental in Mindanao, Philippines. So municipality is, we consider it as a local government unit, which is smaller than a city. Specifically, the study sought to answer the following objectives. First, to explore how local action initiatives are conceptualized, implemented, and sustained in the municipality. And lastly, to explore how the experiences of the municipality can inform the improvement or replication of local action initiatives in other local government units. So as for the significance of the study, so we believe that our study is useful for the local officials, for the residents and the communities, and for the non-governmental organizations, as well as the local government units and the society and environment. Now for the methodology, so this study is a qualitative case study design, which is a thorough examination of the unit to draw broader conclusions involving in-depth data on event and factors. And the study was conducted in a municipality of Misamis Occidental, a local government unit, and the said municipality declared in 2024 a climate emergency. This local of the study focuses on the mangrove restoration, the disaster risk reduction, sustainable management, which aligns with the Sustainable Development Goal 13, which is climate justice. And we have here our participants. We were able to interview 5 local officials, 5 residents of the municipality, and 2 representatives from the non-governmental organizations. And all participants are involved in local climate action initiatives. For our data gathering instrument, so we use the researcher-made semi-structured interview guide. Questions were open-ended, and there were 3 separate interview guides, one for the local officials and local officials of the municipality, another one for the residents, and another one for the representatives of the non-governmental organizations. And then the study employed the YIN's mode of analysis of a case study, which consists of 6 steps. So we have planning, designing, preparing, collecting, analyzing, and sharing. And for the ethical consideration, the study was guided by the ethical principles outlined by Emma Bell and Alan Bryman. So we ensured that the participation of our participants were done voluntarily, and we also upheld honesty and transparency. We made sure that the privacy of our respondents as well as the responses were actually secured. We got informed consent from our participants, and we made sure that there was confidentiality and anonymity among the participants. So here for the findings in our objective 1, which is to explore how local action initiatives are conceptualized, implemented, and sustained in the municipality, we were able to have the first theme, which is the multi-level climate governance. It says here, local climate initiatives are shaped by multi-level climate governance, where the national, municipal, barangay is what we consider as the smallest political unit. A municipality, by the way, for the non-Filipinos in the Philippines, a municipality is composed of barangays. And non-state actors collaborate to coordinate policies, implement climate actions with formal agendas, and align local efforts with national priorities. Although challenges in capacity and institutionalization remain. So this implies that the climate governance in the said municipality enables coherent and well-aligned climate action initiatives supported by strong institutional coordination and evidence-based policymaking through the non-governmental organization and local government unit, NGO representing the private sector, and the local government unit representing the government. Collaboration. So this arrangement enhances the legitimacy and technical grounding of programs, resulting in more organized and policy-driven implementation at the local level. However, it also leads to limited grassroots involvement in the decision-making, which may reduce community ownership and affect the long-term responsiveness and sustainability of climate initiatives. So we recommend that local government units strengthen multi-level coordination while enhancing grassroots participation in climate governance. Mechanisms that allow barangay officials and residents to participate in the conceptualization of climate initiatives should be institutionalized alongside existing top-down structures. Strengthening the feedback systems, participatory planning integration, and inclusive policy formulation can balance vertical alignment with grassroots engagement and improve the overall governance effectiveness. And for our second theme, we have this uneven community participation. We found, based on the study, that the community participation plays a vital role in climate initiatives through local knowledge and collective action, although involvement remains uneven due to barriers, such as limited awareness among the residents, resources in the part of the local government unit, and time and the socioeconomic differences. So this implies that participation is critical for climate governance, yet its uneven nature will produce inconsistent outcomes where some areas benefit from the strong engagement, while others lag behind due to minimal involvement. So this disparity can weaken overall program effectiveness as compliance-driven participation may not translate into genuine commitment, reducing long-term sustainability and community ownership. As a result, initiatives risk becoming dependent on external enforcement rather than internal motivation, limiting their ability to adapt, scale, and even endure over time. So recommend that the municipality adopt participatory planning mechanisms to deepen community involvement. So residents should be included not only in the implementation phase, but also in the conceptualization and evaluation phases of the climate initiatives. Structured community consultations, participatory workshops, and localized planning forums can transform compliance-driven engagement into empowerment-driven participation. And for our third theme, which is the urgent climate action by lived experiences, we found that first-hand experiences of climate-related environmental and livelihood disruptions drive communities to develop urgent, practical, and context-specific adaptation and mitigation actions as lived experiences shape risk perception, strengthen adaptive capacity, and even encourage proactive local responses. This implies that the climate hazards increase community urgency and strengthen support for adaptation initiatives as residents respond more actively to risks they personally experience. This lived experience-driven awareness makes climate action more relevant and widely accepted within affected areas. It ultimately enhances community resilience by fostering proactive engagement and collective responsibility in addressing environmental challenges. We recommend that LGU or the local government unit of that said municipality develop context-responsive climate programs anchored on lived environmental experiences. Climate initiatives should be designed based on the actual vulnerabilities experienced by the residents, such as flooding, coastal erosion, and even the livelihood disruptions. Integrating local knowledge through risk assessment and community-based planning can ensure that programs are relevant, responsive, and grounded on real community needs, thereby strengthening public support and effectiveness. And for our fourth theme under Objective 2, we have this theme, structural and resource gaps. We found that climate adaptation and sustainability initiatives remain difficult to sustain due to limited financial resources, weak institutional capacity, governance challenges, and inadequate policy and infrastructure support, which fragment resilience efforts and hinder long-term sustainability programs. This implies that sustainability of climate initiatives is undermined by persistent limitations within the local government system, financial constraints, manpower shortages, and weak institutional arrangements reduce the efficiency and continuity of program implementation. As a result, climate efforts remain vulnerable to political transitions and short-term planning. By the way, we elect our officers, local government of unit officials in that said municipality every 3 years. This also suggests that without addressing these systemic gaps, even well-designed climate programs may struggle to achieve lasting impact and resilience. And we recommend that the local government unit strengthen institutional capacity and resource allocation to sustain climate initiatives. Addressing financial limitations, human resource shortages, and even administrative burdens requires stable funding mechanisms and establishment of fully institutionalized municipal environment and natural resource office, or we call it here MENRO, with dedicated personnel and technical staff can reduce administrative strain and improve reporting efficiency. Institutionalizing environmental offices and ensuring continuity beyond political transitions can improve long-term sustainability and program effectiveness. And lastly, for our fifth theme, we have here the shared responsibility for sustainability. We found that shared responsibility and sustained collaboration among stakeholders strengthen climate resilience by aligning expertise, resources, and local priorities while fostering community-owned and sustainable adaptation initiatives through inclusive participation and collective decision-making. This implies that collaborative governance are more likely to be sustained and effective when responsibility is distributed among the local government units, the barangays, the non-government organizations, and the community members rather than concentrated in a single actor, like for example, in the local government unit alone. This shared governance structure enhances coordination, accountability, and resource support, leading to stronger implementation of climate programs. However, it also suggests that without continuous collaboration and clear accountability mechanisms, the effectiveness and even longevity of these initiatives of that particular municipality may weaken over time. Thus, we recommend that the local government unit and the non-governmental organization partners may develop long-term sustainability frameworks, institutionalizing the monitoring systems, embedding the climate programs into annual investment plans, and even allocating dedicated funding lines can reduce dependency on temporary political commitment. Continuous non-governmental organization and local government unit collaboration should be formalized through memoranda of agreement to ensure continuity beyond leadership transitions, especially when the elected officials are replaced with the new administrators in the said municipality. And lastly, we recommend that for future researchers, they may explore comparative case studies across municipalities, examining how different LGUs institutionalize climate initiatives, manage vertical reporting systems, and cultivate community participation can generate broader insights for policy replication and scaling of best practices in local climate governance. Okay, and these are the references. And as my parting words, we know that climate change is the defining challenge of our time. It's a test of human resilience, cooperation, and responsibility. Mother Teresa of Calcutta once said, "What we do is nothing but a drop in the ocean. If we did not do it, the ocean would be one drop less." And in this part of the world, we Filipinos continue to challenge ourselves to be that small drop in the ocean. Thank you very much. Maraming salamat po. Mabuhay.
Thank you very much. Stop sharing to discuss a little bit. So to understand exactly, the structure is like that. The barangay is the first level, yeah. After that, you have municipalities, that is
Municipality.
local district, and after that you have town.
No, we have a province.
Okay.
Okay, after we have barangay as the smallest political unit in the country, and the barangay, a group of barangays, is what we call a municipality or a
Okay.
city. A city is bigger than a municipality, and higher than that is the province, which is composed of municipalities and or cities.
Yeah, because for example, in all Europe, you use this term of municipality for the city of over 2,000 years is this issue, but you decrease the level of city to part of the city, something like that.
Yeah.
And this was a small issue about the local approach because in Europe normally the municipality is the city and below you have district, local district, and both have elected government. So it's a little bit different in your country because you have this small barangay who can collect and make one municipality, for example, and more municipality make one city. And the first level of election is to the city, no?
No, we elect officials in the barangay level down to the national
the
level.
first level. So each one have his one. Okay.
Yeah, we have elective officers.
Elected person. Okay, thank you very much. Thank you to use our logo in back of you.
Yeah.
It was
Thank you.
interesting to see also to you. And we will go to the next one if are not other questions. No, are not. Okay, thank you very much. We will go to the impact of climate change on fish farming in Romania, risk and adaptation. The presentation will be made by Aurelia Nica from University of Galați, Dunărea de Jos.
Okay, my name is Aurelia Nica from Dunărea de Jos University, Laura Danube University of Galați, and I will present the paper entitled the impact of climate change on fish farming in Romania, risk and adaptation solutions. I have developed this paper in collaboration with Professor Victor Cristea and Ira Adelin Simionov, Alina Antache, Isabel Metaxa, and Ștefan Mihai Petrea. If we think about what a truth farmer from the Carpathians, a carp farmer from the Danube Plain, and a fisherman from the Danube Delta have in common, the answer is this. All fulfill in different ways the same growing pressure, climate change. Today, I will present you with a synthesis of literature, national and international, on how a changing climate affects Romanian fish farming, what major risks we identify, and most importantly, what concrete adaptation solutions we have at our disposal. The general conclusion is the following. The net impact of climate change on the sector is negative, but the sector's adaptive capacity can be significantly improved. And it is precisely this way of improvement that we will talk about. Fish farming in Romania is made up of 4 major components, each with its own vulnerabilities. The first, we have traditional cyprinid farming, the raising of carp and other cyprinids in dug-out ponds, especially in the Danube floodplain and in lowland areas. Then we have mountain salmon farming, trout farms, which depend on the cold water courses of the Carpathians. The third component in the newest and most expanding is intensive aquaculture in recirculating systems with precise control of water parameters. The purpose of our work was to identify the main climate risk for each of these subsectors and to synthesize the adaptation solutions in order to formulate useful recommendations for both public policies and private investment. Let's start with the most visible risk. Rising water temperatures. A 64% reduction in river areas in Europe that remain sustainable for trout is estimated by 2080. This means that the emblematic species of mountain salmon farming will gradually lose a large part of its favorable natural habitat. The effects of high temperatures manifest themselves on several levels. The first is chronic heat stress. High temperatures affect the neuroendocrine, osmoregulatory, cardiorespiratory, and immune systems of fish. Basically, fish live permanently at the limit of their physiological capacity. The second effect is increasing mortality, especially in cold water species such as trout, which are most exposed during both periods. The third effect is the emergence and acceleration of emerging disease whose incidence geographical distribution of severity had suddenly increased. Finally, we have oxygen deficiency. Thermal stratification of pond water levels to hypoxia, and hypoxia in turn causes massive mortality during heat waves. The conclusion of this risk is clear. The most affected subsector is mountain salmon farming, following by cyprinid farming in pond, especially during hot weather periods. Hydrological drought and reduced flows. The second major risk is hydrological drought. Example, the significant reduction in water flows. Recent data shows that the Danube's flow is over 30% below the multi-year average in certain periods. This decrease generates a chain of cascading effects. Firstly, the natural recharge of the ponds in the ground is reduced, which directly affects traditional cyprinid farming. Secondly, the decrease in the Danube levels leads to the appearance of sandbanks, which affect the access of a water resource. Third, hydrological connectivity is lost in the Danube delta. The inland channels and lakes remain isolated from the main flow of the river. The fourth effects in the emergency of water resource conflicts between aquaculture, agriculture, and industry, all competing for the same increasingly limited resource. And the fifth, perhaps most serious for the delta ecosystem, is the emergence of historically low water levels in the deltas, inland lakes. Additional risk, extreme events, diseases, and water quality. The first is related to extreme meteorological phenomena. Floods can cause fish to escape from reservoirs, damage dams and infrastructure, cause pollution by entering sediments, and introduce invasive species through flash floods. The second category concerns disease, parasitics, and invasive species. High temperatures accelerated the replication of pathogens. Proliferated kidney disease remains a major risk for salmonids. We are whiteness, the expansion of competing species in the Danube Delta, and in general, the emergency of new pathology species to a changing climate. Excuse me, please. The third category is eutrophication and deterioration of water quality. Reduced flows combined with high temperatures accelerate eutrophication. Hypoxia occurs in ponds with reduced water circulation. Damage occurs to both cultivated species and natural ecosystems, and the risk is even greater in pond with a limited supply. If we look at all this risk in synthetic metrics, we notice a clear pattern. Each subsector has its own vulnerable point. Mountain salmon farming suffers the most from temperature. Cyprinid farming and the Danube Delta from drought. Land ponds are exposed to flooding and disease and parasitize effect is in one form or another all subsectors. If we analyze the relative exposure of a subsector on a scale from 1 to 5, the picture becomes even clearer. Upland salmon farming has a maximum score of 5 for both temperature and disease. It is without a doubt the subsector most vulnerability to thermal stress. Pond cyprinid farming and the Danube Delta reach maximum scores for drought, confirming that water shortage is their main threat. Cyprinid farming remains the most exposed to flood and eutrophication, while upland salmon farming is relatively less affected by these two species risks. And now the first solution is the recirculating aquaculture system. They are closed system with water recirculating, which allow precise control of water temperature and quality. Their great advantage is their independence from natural water sources. In practice, to produce is no longer directly depend on the flow of a river or the lake or the level of a lake. Recirculating systems are internationally recognized as a key solution for adapting and climate change and integrated variants such as aquaponics, combine fish farming with plant production in a multi-trophic system. This system also benefits from European funding through the Aquaculture and Fisheries programs, which allocates components specifically dedicated to climate change adaptation. An important aspect, funded projects must include an analysis of climate change immunization, and the program is based on two pillars, blue and adaptation, with European funding for a resilient aquaculture infrastructure. The second solution is represented by species diversification and genetic improvement. The first is the orientation toward more head-resistant species, basically. A shift towards species or varieties less vulnerable to high temperatures through genetic improvement aimed at thermal tolerance. Another solution is protecting the so-called mountain thermal refuge, cold water river sections fed by springs or shaded areas, essentially for trout survival in hot summers. And the third is maintaining the longitudinal connectivity of water courses, which allows fish access to this thermal refuge and spawning grounds. The third solution concerns integrated water resource management with two main components. The first is the integrated management itself, prioritizing water resource between aquaculture, agriculture, and industry, involving the national administration, Romanian waters, coordinating with local authorities during the drought periods, and modernizing the pond irrigation infrastructure. The second component is the hydrological reconnect of the delta, the ecological reconstruction of degraded wetlands with benefits for biodiversity and for mitigating the effect of drought. The fourth solution, essentially for all the other to work, is the institutional framework and public policies. Through institutional play a central role, AMPA, the National Agency for Fisheries and Aquaculture, which offers financial support schemes, energy facilities, and investment for producers. The Ministry of Environmental, Water and Forest, responsible for the PAP 2021-2027. The efficiency of this solution, however, depends on how they are correlated. That is why we have also built a synthetic matrix which links each adaptations solution of a priority subsector and the responsible actors from private producers of PAP funds to the Danube Delta ICDEAPA, the Romanian Water Administration and Environmental. In conclusion, what brings us to the conclusion of this analysis? The first essential message is this: climate change is already an active risk factor for fish farming in Romania, not a distant threat, but a reality that the sector is now facing. The second message is that the impact of different mountain salmon farming suffers the most from thermal stress, while traditional cyprinids farming is particularly affected by water shortages. The third messages concern the Danube Delta, which is feeling the combined effect of drought and loss of hydrological connectivity in a context of continuous decline in catches. The fourth message is an optimistic one. Adaptation solutions exist and are coherent. Recirculating systems, species diversification, water resource, hydrological reconnection. We are not starting from scratch. So, back to the original idea. What do the truth farmer, the crab farmer, and the delta fisherman have in common? All three face of the same climate challenge, but all three can benefit from the same adaptation principles: technology, diversification, responsibly water management, and a solid institutional framework. Romania fish farming can become resilient to climate change through adaptation and innovation, but this requires coordinating action starting now. Thank you for your attention.
I'm Hamami Saber. I'm from the Green Team Laboratory from the National Institute of Agronomy of Tunisia. We are parts of University of Carthage. I will present our work entitled Assessment of Riparian Vegetation Management as a Climate Change Adaptation Measure for Flood Risk Reduction in the Medjerda River in Tunisia. Here is the outline of my presentation. I will start with the introduction and the context. Then I will show you the study area. Next, I will present the material and the methods. I will talk about the characterization of vegetation. I will also explain the hydrodynamic modeling with the Telemark 2D. And I will describe how we set the rootness parameters. Then I will explain the simulated scenarios. After that, I will show the results and discussion, and I will finish with the conclusion and perspective. Floods are very frequent natural disasters. They cause a lot of damage and loss of life. In the Mediterranean basin, climate change is a big threat. Intense rainfall is expected to increase, so floods will become more frequent and more severe. Our study area is in the Medjerda River. It is the largest river in Tunisia. This map shows the town of Buselem. It is located in the alluvial plain of the upper Medjerda Valley. And the section we studied is 7 kilometers long. The town of Buselem is very vulnerable. It experienced several devastating floods between 2000 and 2015. Why are these floods so serious? There are two main reasons. The first is the excessive growth of riparian vegetation. The vegetation increases the hydraulic rootness. This reduces the river's flow capacity, so the water level rises and overflows more easily. And the second reason is the silting of the riverbed. This problem is made worse by dams built in upstream. To solve the flooding problem, dredging works started in 2015. Let me explain the dredging operations. These works had three main objectives. First, remove the vegetation, especially the tamarisk which blocks the river. Second, widen the channel. The width increased from 20 to 18 meters. This allows more water to pass through. Third, build bank levees. This helps to contain the water in the channel. They also delimited the floodplain. The floodplain is 100 to 200 meters wide. This is to limit construction in high-risk areas. This slide shows the location of the works. You can see the bed occupation before the works, and you can see the bed occupation after the works. The problem is clear. This is excessive riparian vegetation. The tamarisk dominate the area. It increases hydraulic rootness. This reduces the flow's capacity, and it raises the water levels and promotes flooding. Vegetation characteristic. Now, the dominant species is tamarisk. He covers both banks almost continuously. It has a strong ability to growth back after dredging. In area near homes, it grows as bushes. The height is between 0.5 and 3 meters. The coverage is between 25 and 15%. In area not maintained for more than 5 years, it is different, and the tamarisk can reach height of up to 10 meters. The trunk diameter can be 20-30 centimeters. It forms very dense thickets. These thickets significantly reduce the flow's capacity. There are also other species present. They plays a minor role. We study the flow. We use two-dimensional hydrodynamic models. The model is called Telemac 2D. Why did we use Telemac 2D? First, it solves the Sun-Venant equation. This equation describes the flow of water on a surface. Second, it works on an unstructured mesh. This means we can refine the mesh in important areas. For example, we use a fine mesh in the river channel. We use a coarser mesh in the floodplain. Third, it allows us to integrate vegetation resistance. We can use specific friction laws for vegetation. And fourth, it allows accurate circulation of fluid volumes. It also helps us map the floodplain in detail. This is what the two-dimensional mesh look like. You can see the variable density of elements. The channel has very small elements. The floodplain has larger elements. This balances accuracy and computation times. Now let me explain the roughness parameterization. We used the Nicarazzi roughness coefficient. Telemac 2D recommends this law for model with vegetation. Why? Because law is independent of water depth. We split the total roughness in two parts. First, the bed roughness needed lambda prime. This represents the mineral substrate of riverbed. Second, the vegetation roughness noted lambda double prime. This represents the resistance from the plants. We used the principle of linear superposition. The total roughness is the sum of both parts. Lambda equals lambda prime plus lambda double prime. The distinction allows us to adjust each part separately. We can control the influence of the bed. The vegetation effect. We use the Baptiste approach. This approach is very useful. It treats both insubmerged and submerged flow. It considers the vegetation as a set of rigid cylinders. The formula for vegetation roughness depends on the water depth. If the water is shallow, we use one equation. If the water is deep, we use other equation. The parameters we need are the drag coefficient, the mean stem diameter, the average spacing between stems, and the height of vegetation. We determined these parameters from field survey. Then we adjust during the calibration phase. The slide shows the calibration results. Here are the optimized parameters for vegetation. The drag coefficient is equal to 1. The stem diameter is 0.1 meters. The spacing between stems delta is 1.15 meters, and the vegetation height is 4 meters. These values minimize the difference. We compared simulated water levels with observed water levels. This validated Baptiste approach. It works well for the hydraulic condition on the Medjada River. Now let me present the two scenarios we simulated. We simulated the historic flood events for 2003. The flood severely affected the town of Buselem. We used the same input for both scenarios. The input was the same flood hydrograph. That means the same volume of water entering the river. The first scenario is the current state. This represents conditions after the dredging works. The channel is widened, the riparian vegetation is reduced. The second scenario is the reference state. This represents a condition before the dredging works. The vegetation is dense. The tamarisk obstructs the main channel. We compared these two scenarios. The goal was to see the effect of dredging. We wanted to measure the reduction in flooding. Now let us look at the results. This slide shows the comparison between the two scenarios. On the left, you see the reference scenarios. This is before the dredging works. The vegetation is dense, the flood is very large. On the right, you see the current scenario. This is after the dredging works. The vegetation is reduced. The flood is much smaller. The difference is very clear. In 2003, the flooded area was 413 hectares. That is 74% of city's total area. It was a disaster, and the current condition, the flooded area is only 83 hectares. That is only 15% in the city. So the flooded area was reduced by about 18%, or in terms of the city proportion, it is a 59% point reduction. This is a huge improvement. What caused this improvement? There are three main reasons. First, the bank levees confine the flow to the channel. Second, the widening of the channel increases the flow capacity. And third, the vegetation removal reduces the hydraulic roughness. This is lower the water level for the same discharge. Now let us look the hydraulic effect of vegetation. For the same amount of water, dense vegetation causes several problems. First, it raises the water levels. Second, it reduces the flow speed inside the channel. Third, it makes the water spread out over the floodplain. The flooded area becomes larger. On the other hand, vegetation removal does the opposite. It lowers the water levels, it increases the flow speed, and it improves the river's ability to carry water. This reduces the floodplain area, so riparian vegetation acts as a major hydraulic regulator. It has a very strong control on the flow. This confirms that sustainable management of vegetation is essential. This is especially true with climate change. We must manage it carefully. Now let us discuss the trade-offs. Dredging is effective, but it is not without consequences. Let us look at the benefits first. In the short term, it reduces flood risk, it protects urban area like Buselem, and it increases the channel's capacity to carry water. These are very positive effects. But there are also drawbacks. In the long term, dredging changes the sediment balance. It increases the transport of sediment downstream. This accelerates the silting of the dams. The dams loses its storage capacity. This threatens the country's water resources. So we have difficult choice. We must balance flood protection and water resource sustainability. Additional study in the same river section have shown this clearly. The removal of riparian vegetation reduces bank roughness. This increases sediment transport. The eroded sediment go in the downstream. They contribute to the siltation of the dams. This interaction between vegetation and sediment is very important. It must be integrated into long-term management. Let me now summarize the main finding and conclusion. First, vegetation management is very effective. Dredging and tamarisk removal significantly reduce flood risk. the flooded area was reduced. This is through channel widening, bank levees, and reduced roughness. This confirms that vegetation management is good adaptation measure. It responds to the projected increase in flood risks. This is important for Mediterranean watershed affected in climate change. However, we cannot apply this strategy everywhere. It has longer-term side effects. Riparian vegetation plays dual role. It is both a hydraulic barrier. We must manage it to prevent flooding, but it is also morphological stabilizer. We must preserve it to limit erosion, and we must preserve it to limit downstream siltation. So we cannot just remove all the vegetation everywhere. We need balanced approach. This is the main of dilemma for river manager. So how we move forwards? We need a balanced compromise. We should maintain vegetation strips in erosion-prone area. This helps to protect the banks and limit erosion. And we should focus dredging operation on vulnerable urban sectors. This is where flood protection is most needed. And thank you for your attention.
Thank you very much. Stop the share. Okay. And first, I want to thank you for your presence because it's not first time we see together. We saw you also in the past. From this presentation, I understand this management vegetation is not the universal panacea to can resolve all the issue. And you need to be very smart when to put this kind of management approach to don't destroy the river. This is the idea also from your presentation. And my question is this: how often the flood are in this river? It's each 2 months, one of the year when go up.
No, we don't have flooding this time because climate change drove that. The last were 2015, and the construction of the dams in upstream decreases the
So
flow.
the problem is resolved by hydro construction.
By hydraulic construction, yes. And when the phenomenon of when we have flooding, that we observe the effect of vegetation, and now we can observe this. But in the future, this
so it will be a mixed situation. You can keep to the dam and some with the management of vegetation, basic, and with climate change, the problem is resolved.
Yes, flood protection and water resource sustainability. This is the approach to manage river.
Okay. Thank you very much for your presence and for your paper. If are not other questions, we will go to the next presentation because there are so many.
Today, I'll be presenting my proposal called Climate Memory Farms. When discussing climate change, we often focus on reducing emissions or developing new technologies. While these approaches are essential, I believe another important question deserves more attention. Can we prepare living organisms themselves to better withstand climate change? Agriculture and aquaculture are becoming increasingly vulnerable to rising temperatures, droughts, changing rainfall patterns, and declining water quality. Current adaptation strategies mainly focus on protecting crops and aquatic species from these environmental changes. My presentation explores a complementary approach, one that aims to strengthen the resilience of the organisms themselves through the concept of biological stress memory. Today, I will explain the scientific inspiration behind this idea, how it would potentially work, and why it may contribute to future climate adaptation. The climate crisis. Climate change is no longer a distant prediction. It is already affecting food production across the world. According to international climate assessments, global temperatures continue to rise while extreme weather events such as droughts, floods, and heat waves are becoming more frequent and more intense. These changes create serious challenges for both agriculture and aquaculture because they depend directly on environmental conditions. What stands out to me is that many current adaptation strategies are designed to protect the environment around crops and fish. We build irrigation systems, improve forecasting technologies, and strengthen infrastructure. These solutions are extremely valuable, but they mostly address the external environment. This raises an important question. If climate change continues to intensify, should we also explore ways to improve the biological resilience of the organisms we rely on for food production? Challenges in agriculture. Agriculture faces several interconnected challenges as the climate continues to change. One of the most significant is prolonged drought, which reduces water availability and limits crop growth. At the same time, increasing temperatures place plants under heat stress, affecting flowering, pollination, and overall productivity. In many regions, rising soil salinity creates an additional problem by making it more difficult for plants to absorb water and essential nutrients. Another important challenge is uncertainty. Farmers are no longer dealing with occasional extreme weather events. Instead, they must plan for increasingly unpredictable growing conditions, making agriculture management much more difficult. These combined pressures threaten both food production and global food security. Challenges in aquaculture. Aquaculture experiences many of the same climate-related pressures, although they occur in aquatic environments. As water temperatures increase, fish and shellfish experience greater psychological stress. Warmer water also contains lower levels of dissolved oxygen, making survival and healthy growth more important. Climate change can also increase the frequency of disease outbreaks while disrupting the balance of aquatic ecosystems. Together, these factors reduce productivity, increase mortality, and create financial challenges for aquaculture producers. Because global demand for seafood continues to increase, improving the resilience of aquaculture systems has become an important priority for sustainable food production. Current adaptation strategies. Researchers and farmers have already developed many valuable strategies to reduce the impact of climate change. Examples include improved irrigation systems, climate monitoring technologies, stronger infrastructure, and selective breeding to develop more resilient crop varieties and aquatic species. These approaches have produced important improvements. However, many require significant financial investment, advanced technology, or long periods of development, making them less accessible in some regions. This observation led me to ask a different question. Rather than focusing only on protecting production systems from climate change, could we also strengthen the natural resilience of the organisms themselves? That question became the starting point for the concept of climate memory farms. A new perspective on climate adaptation. Current adaptation strategies have made remarkable progress in helping agriculture and aquaculture respond to climate change. However, most of these approaches focus on managing the environment surrounding crops and aquatic species. Climate memory farms offers a different perspective. Rather than asking only how we can protect organisms from climate stress, it considers whether we can strengthen their natural resilience before those stresses occur. This framework does not replace existing technologies or management practices. Instead, it proposes adding another layer of adaptation by exploring how biological stress memory may help organisms respond more effectively to future environmental challenges. This shift from protecting organisms to also preparing them is the central idea behind memory farms. The concept of climate memory. The idea of climate memory farms is inspired by an area of research known as biological stress memory. Scientists have observed that some plants can respond differently after experiencing mild environmental stress. For example, a plant exposed to a short period of drought may activate protective mechanisms more quickly if drought occurs again later. Similar adaptive responses have also been observed in some aquatic organisms under carefully controlled conditions. This does not mean that organisms become immune to climate change. Instead, it suggests that previous exposure to manageable levels of stress may influence how they respond to future challenges. Climate memory farms proposes this scientific principle in a controlled and ethical way to explore whether resilience can be strengthened before severe climate events occur. How climate memory farms work. The proposed framework follows four main stages. First, young crops or aquatic organisms would be exposed to carefully controlled and non-harmful environmental stress, such as mild heat, limited water availability, small changes in salinity, or reduced oxygen levels. Second, they would be given sufficient time to recover. During this period, biological processes associated with stress adaptation may occur. Third, this process could be repeated under carefully monitored conditions to encourage stronger adaptive responses. Finally, when natural climate extremes occur later in development, these organisms may be better prepared to tolerate environmental stress. I would also like to emphasize that this is a proposed framework inspired by existing scientific research. Further experimental studies would be needed before it could be applied on a larger scale. Agricultural applications. If future research supports this concept, climate memory farms could have several practical applications in agriculture. Young crops might undergo carefully controlled environmental conditioning during early growth stages. The objective would not be to eliminate stress entirely, but to expose plants to manageable levels that encourage stronger future responses. This approach could potentially improve tolerance to drought, extreme heat, and changing soil conditions while helping maintain more stable crop productivity. If successful, it could become one additional strategy alongside irrigation. Improved crop genetics and sustainable farming practices, contributing to stronger food security under changing climate conditions. Aquaculture applications. The same concept may also have potential applications in aquaculture. Fish and shellfish experience increasing environmental stress as water temperatures rise and oxygen availability declines. Climate memory farms proposes that carefully controlled exposure to mild environment and changes during early life stages may encourage stronger psychological responses later in life. If supported by future research, this approach could improve survival rates, reduce mortality during extreme environmental events, and contribute to more stable aquaculture production. Rather than replacing current management practices, it would work alongside existing technologies to strengthen the overall resilience of aquatic food production systems. Expected results. If the climate memory farms framework proves effective through future research, it could provide several important benefits for both agriculture and aquaculture. One possible advantage is increasing the survival of crops and aquatic species during periods of environmental stress. Even a small improvement in resilience could help reduce production losses during heat waves, droughts, or changes in water quality. Another benefit is greater stability in food production. Climate change is making harvests and aquaculture yields more unpredictable, which affects both farmers' incomes and food availability. By improving biological resilience, production systems may become more reliable even under changing environmental conditions. The framework may also help reduce economic losses by lowering mortality rates and decreasing the need for emergency interventions during climate extremes. Most importantly, climate memory farms is not intended to replace existing adaptation strategies. Instead, it could work alongside irrigation systems, climate monitoring technologies, improved genetics, and sustainable management practices to create a more comprehensive approach to climate adaptation. Potential global impact. Although this framework is still a proposal, its potential impact could extend far beyond individual farms. Climate change affects every region differently, but nearly all countries face increasing pressure on food production. Developing nations are often the most vulnerable because they may have limited access to expensive adaptation technologies. If biological resilience could be strengthened through relatively simple and carefully managed methods, this approach might become more accessible than relying entirely on costly infrastructure. Climate memory farms could contribute to stronger food security, support sustainable agriculture development, and improve resilience in communities that are most exposed to climate risks. Beyond agriculture and aquaculture, I also hope this concept encourages researchers to think differently about adaptation, not only by changing environments, but also by understanding how living organisms themselves respond to environmental change. Implementation roadmap. Like any scientific idea, climate memory farms would require careful testing before practical implementation. The first step would involve controlled laboratory and greenhouse experiments to investigate how different species respond to carefully managed environmental stress. If early studies produced encouraging results, researchers could move to pilot farms and aquaculture facilities where the framework could be evaluated under real production conditions. The next stage would involve comparing results across different climates, crops, and aquatic species to determine where the approach is most effective. Only after through scientific evaluation should larger scale implementation be considered. This gradual process is essential because successful climate adaptation must always be supported by reliable scientific evidence. Future possibilities. Looking ahead, I believe this concept opens several exciting opportunities for future research. Artificial intelligence could help identify the most effective stress training conditions for different crops and aquatic species by analyzing large amounts of environmental and biological data. Researchers could also investigate whether different species require different stress condition strategies, allowing adaptation methods to become more precise and efficient. Another interesting possibility is integrating climate memory farms with precision agriculture, smart farming technologies, and climate forecasting systems. Rather than viewing biology and technology as separate solutions, future adaptation may combine both to build stronger and more resilient food production systems. Conclusion. In conclusion, climate change is one of the greatest challenges facing global food production, and finding new ways to adapt will become increasingly important in the years ahead. Climate memory farms is not presented as a finished solution. Instead, it is a proposed framework inspired by emerging research on biological stress memory. The idea is to explore whether carefully managed environmental conditions could help strengthen the resilience of crops and aquatic organisms before they experience severe climate stress. I believe the greatest value of this concept is not only its potential application, but also the different way it encourages us to think about climate adaptation rather than focusing solely on protecting food production systems from environmental change. It asks whether we can also strengthen the natural resilience of the organisms that those systems depend on. While further scientific research will be essential to evaluate this idea, exploring innovative approaches such as climate memory farms may contribute to building more sustainable and resilient agriculture and aquaculture systems for the future. Thank you very much for your attention and for taking the time to listen to my presentation. I sincerely appreciate this opportunity to share my proposed framework with you all, and I hope it has provided a fresh perspective on how biological resilience may contribute to future climate adaptation. Thank you once again. If there are any questions, I'll be more than happy to answer them.
We'll see now. First, stop to sharing the image to can see together.
Yes, of
Okay.
course.
So first question is from me. It's you discuss about climate memory. Basic, this is like biological adaptation.
Yes.
Now, and this concept of climate memory, it's very interesting. And your approach was to introduce us in this field of information, because your presentation was generally presentation, is not like to go to make a research in one area. The question is this: in the future, you want to go to make research in one area like that, or it's only a paper for the school?
Honestly, to answer your question, I would love to go into that area of study. I would love to know more about climate memory farms. At the moment, this started as a research proposal developed for this conference, but it has also sparked my interest in this field. But it has also sparked my interest in more things like climate change and global warming. In the future, I would like to explore biological adaptation and climate resilience in greater depth, particularly through scientific research, as you said. I believe climate memory farms has potential as a conceptual framework, and I hope that with more knowledge and collaboration, it could eventually be investigated through experimental studies. So for me, this is more of like a school project, but I would love to go and study it as more of a maybe a job career future opportunity in my life, maybe through college or other courses. So it has inspired me to continue learning and possibly contribute to this area of research in the future.
You already make the first step, so you have an idea, and in the future, we don't know. Probably you'll see again. I don't know. Okay. If are other questions from the people who are online.
Yes. Hello, Nirvana. Sorry, but I don't understand. What are you studying now? What is your profile to study?
My profile to study is more into biology, political science. Right now, I'm studying the general secondary school curriculum, which includes subjects such as biology, chemistry, physics, and mathematics. Although I have not yet specialized in a particular field, I have a strong interest, as I said, political science, climate change, biological research, which inspired me to develop this proposal.
Okay, thank you. Thank you.
So thank you very much for your present, for your paper, and we will continue with others. Thank you very much.
Yes, thank you so
much. We need to running the show. Next presentation, it's from Tunisia, the effect of climate change and carbon dioxide emission on crop production, evidence from Tunisia.
Our contribution entitled The Effect of Climate Change and Carbon Emission on Crop Production in Tunisia. Generally, Tunisia is a country characterized by its arid and semi-arid climate, and this factor influences the agricultural output. The relationship between climate change and crop production has become a critical area of research due to the increasing frequency of extreme weather events like rising temperature and shifting precipitation. that adversely affect agricultural productivity in Tunisia. In this direction, our target is to answer to the following question: how can Tunisian agriculture sector adapt to the challenge posed by climate change and to ensure sustainable crop production? In this way, our study is structured as follows. Firstly, we started by the introduction. Section 2 is devoted to literature overview. This section 3 is reserved to the methodology. This section 4 is we represent the empirical finding, and finally the conclusion. So, agriculture is one of the most climate-sensitive sectors, playing a critical role in ensuring food security and supporting economic growth, especially in developing countries like Tunisia. For example, rising temperature, irregular precipitation, and extreme weather events pose significant challenge to agricultural productivity. This challenge threatens not only crop yields, but also sustainability of agricultural practice. In this context, understanding the dynamic between climate change and crop production become vital to planning strategy that can mitigate negative impact and promote sustainable agriculture. Moving to the literature of review, we can cite, for example, Ahmed and Ben Mustafa 2024 found that wheat, barley, and olive oil the agriculture output in Tunisia are particularly sensitive to rising temperature, with yield decline reaching up to 10% in some regions. Also, we can note that Siva Kumar et al. Found that temperature can increase, the increase of temperature can reduce agricultural productivity or crop yields. In order to validate our study empirically, we are inspired from research realized by Zhang et al. 2023. The dependent variable represent the crop prediction, and the explanatory variable are the temperature, precipitation, Arab land, fertilizer consumption, and carbon emission. Yes, we obtain the equation number 1, the crop production as a function of temperature, precipitation, land, fertilizer, and carbon emission. After that, we apply the logarithmic form, which is designed by equation number 2, and after that, we apply the NRDL model, which is designed by equation number 3. Firstly, we started by the statistical analysis. Then we check the stationarity by using augmented Deckel-Fuller and Phillips Perron, and then we apply the NRDL model. So, after confirming that all variables are co-integrated in different order, some variables are co-integrated in order 0 and the other in order 1, we can apply the NRDL model. As a result, we found that firstly, the value of the CT is negative, which is a basic condition to reach the long-run equilibrium. Then we can observe that the positive and negative shocks of carbon emission for example, the positive shock of carbon emission in the short and the long run has a positive effect on crop production. So we can note that the increase of carbon emission can improve plant growth and biomass accumulation. We can observe also that the positive and the negative temperature have a negative impact, especially in the long run. So we can note that positive or negative temperature shocks adversely affect crop production in Tunisia. So both warming or cooling shocks negatively affect crop production. We can conclude that while higher temperature generate a positive shock, the positive shock can increase the crop production that generate stress and intensify water scarcity, but lower than normal temperature can reduce plant metabolistic activity and delay crop development. So in Tunisia, agriculture is highly sensitive to climate variability. Also, we can observe that the positive shock of precipitation has a positive effect on crop production in the short run, but in the long run is not significant. Also, in negative shock in precipitation has a negative effect on crop production in both in the short and the long run. So the positive shock, when the positive precipitation increase, the crop production also increase. Precipitation can improve soil, enhance water availability, and reducing water stress. As a conclusion, so we can conclude where the agricultural sector faces challenge related to soil quality and climate variability, fertilizer can play a strategic role in maintaining productivity, and rainfall that occur outside critical growing period may not benefit crop, and in same case can disrupt agricultural activity, such as planting delays, seed germination failure, or crop losses. So it's necessary to introduce climate smart technology, for example, encouraging practice such as soil conservation and modernizing irrigation infrastructure. So thank you very much for your attention.
So my name is Yaroslav, and I'm speaking on behalf of my CEO authors, Sergei Verbitsky and Natalia Patsara from the Institute of Food Resource in the National Academy of Agrarian Science of Ukraine. Our presentation today addressed what we believe in one of the most urgent challenges in agricultural science. In intersection of climate change and war of compounding risk to food system. We will focus on Ukraine, a country that is living through this challenge right now and extraordinary scale. To understand to understand the scale of war is at stake, let me briefly of Ukraine's position in global food security. Before the full-scale invasion, Ukraine supplied approximately the percent of global wheat trade and close of 40% of global sunflower oil exports. The country agricultural system is built on some of the most fertile soil on earth, the Chernozem Belt, combined with well-developed agro-industrial infrastructure. The southern regions and in particular the Kherson Oblast combined intensive irrigate farming with strong food processing industries. So the first category of climate change, Ukraine has experienced measurable warming over recent decades, with the southern and eastern regions most affected by increasing drought frequency, declining soil moss, and irregular precipitation. These trends are projected to intensify. The second category is full-scale war since February 2022, with its destruction of water and energy infrastructure, land mining, displacement of farming communities, and disruption of environmental monitoring system. What makes Ukraine's situation analytically and globally important is not that these two risks exist simultaneously. It is that they interact. War destroyed the very infrastructure through which cities adapt to climate change, and climate stress hits hardest precisely in the region most damaged by war. The result is a compound risk greater than the sum of its part. Let me briefly characterize the climate dimension. Surface temperature across Ukraine have increased by 1 to 1.5 degrees Celsius over the past 3 decades, with certain regions warming faster. Precipitation patterns have become more irregular, growing season water deficit, and already a measurable constraint for farmers in the steppe zone. Our projection for Eastern Europe suggests continued warming and increasing precipitation variably. Modeling exercise indicate a potential reconduction of the to hugely % for major crops in South Ukraine, but mine century without adaptation. Actually, the war amplifies this climate risk through 5 mechanisms, and I want to emphasize each. First, water infrastructure destruction. Irrigation system and pumping station have been destroyed in conflict-affected area, eliminating adaptive capacity where climate water stress is more acute. Second, land contamination, trout mining, and explosive remines, which restricted the flexibility of farming system to adapt. Third, displacement of farming communities, which erodes the human capital required for adaptive management. Fourth, attack on energy infrastructure, which undermine the operation of irrigation and precision agriculture. And fifth, disrupting of methodological and environmental monitoring networks, reducing the information base essential for evidence-based adaptation. The most dramatic single materialization of this compound risk is the destruction of the Kakhovka hydroelectric power plant in June 2023. Total damage and losses nearly $40 billion US. Territory fluid in the immediate aftermath. Approximately 620 square kilometers. People directly affected around 100,000. Estimated recovery needs over $5 billion. But beyond this immediate figure, the Kakhovka event is analytically important because it's instantly, suddenly, violently, completely, exactly the type of chronic water streets that climate projection indicate will gradually affect southern Ukraine over the coming decades. Military action compressed decades for projected climate risk into a single event. Okay, the next. Looking specifically at agriculture, the irrigation dimension in the Kakhovka catastrophe is catastrophic in its own right. 94% of irrigation system in Kherson Oblast lost their water supply. 31 irrigation system across southern Ukraine ceased operation. 584,000 hectares of agricultural land were left without irrigation. According to the fourth rapid damage and need assessment, the 150 pumping station and 1,100 kilometers of irrigation canal remaining non-functional. The assessed recovery needs for irrigation and water resources in Kherson Oblast alone stand at $1.85 billion US, the highest figure among all Ukrainian regions. From this analysis, we can identify four risk groups for the regional food system. The first is the chronic water deficit. The psychical absence or irrigation water for crops that required it, with no short-term solution in sight. The second is soil and land degradation, sealing, salinization, chemical contamination, and the accumulation of heavy metals in food chain, creating food safety risk that extend for beyond the flooded zone. The third risk group is the erosion of the raw material base for food processing, falling capacity utilization in agro-industrial enterprises, loss of local value chains, and contraction of rural employment. And the fourth, perhaps the most strategically significant, is the potential permanent loss of Kherson Oblast role as one of Ukraine's key agricultural region. This is not just about current production, it's about the long-term agricultural specialization and economic identity of entire region. Ukraine's situation is extreme in scale, but is not analytically unique. Research other conflict-affected agricultural environment documents other countries. We have some patterns. Conflict destroy water and land management infrastructure. Displacement disturb traditional adaptive practice, and post-conflict recovery focused exclusively on restoring pre-conflict production system tends to reproduce climate vulnerabilities rather than restore them. International framework, the EU climate adaptation strategy, the Paris Agreement, the Sendai framework for disaster risk reduction offer relevant guidelines. They share a key insight. Adaptation must be systemic, cross-sectoral, and must integrate climate resilience into infrastructure and government design. Actually, building on this analysis, we propose 5 integrated adaptation pathway that must be pushed actually not sequentially and not is isolation. It will be briefly described each one. Pathway 1 is climate start reconstruction of weather infrastructure. The key work here is smart. The rebuilding of irrigation system provides a rare opportunity to redesign water management architecture for greater climate resilience. This means moving away from depends on large centralized infrastructure toward decentralized system with small-scale storage, drip irrigation, precision water management. Pathway 2 is adaptation to pathway 2 is adaptation of crop structures and farming system. In zones where pre-war irrigation cannot be quickly restored, farming must transition toward drought-tolerant varietals, rainfield production, and delivered land use. This transition must be informed by climate projection, not simply by what was grown before the war. Pathway 4 is a digital infrastructure for compound risk monitoring, rebuilding methodological networks, integrational satellite and AI-based early warning system, and developing digital platform for agricultural risk management address both climate vulnerability and the information deficit created by conflict. Pathway 5 is the irrigation of climate adaptation into recovery governments. This means that climate resilience must be a core objective of recovery planning from day one, not added as an after Hauch. Recovery plans must include climate performance indicators, reference climate projections, and establish review mechanism that update and both science and conditional evolve. The Paris Agreement, the UE adaptation strategy, and the Sendai framework all provide relevant institution model. Sorry. Actually, conclusions. Let me close with you conclusions. First, Ukraine face a compound risk challenge with which climate change and war interact to produce greater than either work generate in isolation. The Kakhovka catastrophe is the most damaging single illustration of this. An event that compressed decades of projected climate stress into a single military act. Second, Ukraine experienced in the largest and most documented case of the global climate conflict nexus. The lesson drawn from it have implication far beyond Ukraine's borders for any region where climate stress and conflict risk increased. Tried. Post-conflict reconstruction offer a rare window for transformation climate adaptation. The critical condition for capturing this opportunity is integrating climate resilience from the outset, not treating recovery and climate adaptation as parallel, separate agendas. And for the 5 integration pathways we proposed must be pursued and coherent systemic framework. I'm sorry. Pursuing any one is isolation will not be sufficient. Ukraine deserves both reconstruction support and climate adaptation investment, and the international scientific community includes all international community can play a role in generating the evidence base that makes both more essential. Actually, thank you for your time. Sorry for my English.
Okay, stop sharing. The English is not a problem. So, from what I understand from your paper on the conference, you tell us basic something like that. The all agriculture in Ukraine will be changed from 2 reasons: the war and the global climate change, and these 2 affect everything in the Ukrainian agriculture. But it's also a good way because you already signed the agreement with the European Union, and so will be implemented the new policy on the Ukrainian agriculture. And this policy will be, more adaptive to the new reality of the world, climate change, information structure of line for production and for supply. So basically, now you are in a phase to move from one method to another one.
Actually, yeah, you are right, and I should add in the full scale in 2022 in Ukrainian provide many different interested technology in many scientific and environmental sphere, actually. And for example, in medical sphere, for example, in same agricultural sphere, I'm not talking about different communication technology and different R&D solution. So actually, and unfortunately, in current time, we have some condition. It's not good condition, but it's situation give, I think, huge experience to find solution in actually and in ecology problem too.
Basic, the war accelerate all this change. This is the basic. The war accelerate.
Actually, yeah, if we saw in history previously war and each technical solution or it's in other things give a start for as a solution for war, and another after war rebuilding some solution completely
in the agriculture. Yeah. Okay. Thank you very much. Was very interesting the presentation. I don't know this catastrophic you told us, but I see the destruction in Ukraine because I was many times after the war start in Ukraine, so I know exactly because I was there to help kids to bring in Romania, and I saw damage on agriculture, and probably when the conflict will end, will be the time to reconstruction because for a lot of country, Ukraine it's a very good supplier, especially the country in Arab area, and this now have big problem to get crops or other kind of food from Europe because European Union have indeed a lot of production. We can give a lot of production, but are some restriction regarding the policy and other issue like that. But Ukraine was the main supplier for a country like Egypt or Jordania or Saudi Arabia and others like that. And this war changed a little bit the flux of crops in the region. And probably after the war will change again to be again the supplier of this country, because now, for example, we in Romania we suffer a lot of crops from Ukraine who can pass to Romania, and they don't pay so many taxes like us, and for this reason the price is different and it's lower and affect a lot of agriculture industry in Romania, and not only in Romania, also in Slovakia and Hungary and Poland. And because you cannot sell where you sell normally the food.
Actually, this war show some intelligence and some
surprise for you.
Actually, not only for me, actually. And actually, you're right. And thank you, you, and thank you, partner, for helps. And I hope this war find his end very quick.
Yeah, I also agree with this. Gas station will be the when we'll be empty, the gas station will be finished. Okay, so we will go to the next presentation. Next presentation comes from Bangladesh. It's about coastal erosion control and climate adaptation. Abu Musa, if it's online, I already saw. Hi, Abu.
Hello, am I audible?
Very good. So we want to share your presentation and to start to present your paper about this oyster reef.
Can you see this, my
Yeah,
presentation?
yeah, perfectly. Put on full screen and we'll be okay.
It's okay?
Yeah, you can start.
Thank you. Assalamu alaikum and good evening to everyone join us from around the world. My name is Mohammad Abu Musa and I'm a student in oceanography and hydrography at Bangladesh Maritime University. Today I am honored to present my topic, oyster reefs and riparian vegetations, what we call in integrated bioengineering approach as a natural-based solution for coastal erosion and climate adaptation in Bangladesh. Let us quickly walk you through what we will cover today. Here have 8 key sections from the problem context to the research gap. Our study area at specifically Bhola Island, we proposed bioengineering framework, our methodology, key findings, and policy elements, and findings or conclusion and the way forward. Let us begin the scale of the problem. Bangladesh has 1,419 kilometers of vulnerable coastline and approximately 20 million people whose livelihood, homes, and food security depend directly on that coastline remaining intact. Climate projections tell us that sea level along Bangladesh coast will rise by up to 60 centimeters by 2100. At the same time, cyclone intensity is increasing 3 to 5 times above historical average. These are not distant threats, they are happening right now. At Bangladesh Island, specifically our study area, the shoreline is retreating at the rate of 50 to 200 meters per year. That means some communities are losing their equivalent of a football field, of land, every single year. Cyclone storm surges are exceeding 5 to 8 meters, and saltwater intrusion is killing the every vegetations that naturally protect these shores. The consequences are devastating: loss of agricultural land and fisheries livelihoods, displacement of entire coastal communities, contamination of freshwater aquifers, and the collapse of ecosystem that more than 30 million people depend on for their survival. Main question, how has Bangladesh traditionally responded? Mostly through hard engineering like concrete seawalls, embankment, and rebatements. This cost USD 1 to 3 million per kilometer. They require intensive maintenance every 5 to 10 years. They do not restore any ecological function, and they often make erosion worse and unprotected plants by concentrating wave energy. This is a resource gap, natural-based solution. Our approach cost as little as USD 50,000 to 2 million per kilometer. The system is self-repairing. Once the oyster reef established, it grows naturally. It restores biodiversity, it enhances fisheries, and it directly aligns with Bangladesh Natural Adaptation Plan and IPCC guideline and NBC. This means natural-based solutions. Our study focused on Bhola Island, Bangladesh's largest island district located in the Borishal division at the mouth of the Bay of Bengal. It is home to approximately 1.8 million people, predominantly coastal fishers and farmers who are deeply dependent on the stable shoreline. We selected Bhola for 4 strategic reasons. First, it has the higher erosion intensity in Bangladesh intercoastal zone. Second one is Pastoria madarensis, The Indian backwater oyster, ocean naturally in Bola waters, dramatically reducing the coast reef establishment. And third, diverse riparian plant species suitable for more development already exist in the region. And fourth, extensive remote sensing archives and hydrological record are available for rigorous scientific analysis. Our target species are Crassoria matherensis for the reef layer and vetiver grass Nympha fruticans and Pharmatis carca for the vegetation belt. All are native species, meaning this intervention works with the local ecology, not against it. At the heart of the research is a dual zone bioengineering framework. The two zones function together, and the synergy is what makes this approach far more powerful than either element alone. Like zone 1 is the submerged oyster reef deployed at 0.5 to 2 meters water depth in the subtidal zone. The reef physically intercepts incoming waves, dissipating 70 to 90% of wave energy before it reaches the shoreline. It reduces bed shear stress, allowing sediment to settle and build up. The reef matrix provides habitat for juvenile fish, generating immediate fisheries co-benefit. And because oysters are self-recruiting, the reef grow and expand naturally over time. Now talk about zone 2. Zone 2 is the riparian vegetation belt, plant on the intertidal and subtidal zones above mean sea level, root system and vetiver, Nympha and Pharmatis anchor that substrate and reduce erosion by 60 to 80%. The vegetation canopy absorbs storm rainfall and limit surge overtopping. It increases sediment deposition rate by 2 to 4 times above baseline, and it sequesters 2 to 8 tons of carbon per hectare per year, making it eligible for blue carbon credit schemes. The synergy is critical. The oyster reef protects the vegetation from the wave damage while it established, and the vegetation established the sediment that the reef helps accumulate together. They create a self-reinforcing coastal protection system that improves over time. To validate this framework rigorously, we designed 6-method research approach, each method addressing the distinct dimension of the problem. Like method 1, we began to Prisma systematic review of 180 global studies on viable-based, natural-based solution to understand what works and what doesn't. Internationally, we then conducted a GIS multi-criteria suitability assessment, integrating hydrodynamic exposure, salinity gradient, bathymetry, sediment dynamics, and biodiversity data to identify optimal deployment zones at Bola Island. Now, method 2, a 3-round Delphi expert consultation with 15 coastal engineers and ecologists generated consensus on design parameter, field validation involved in situ sediment cores, oyster density, transect, and vegetation quarters directly at the study site. Wave attenuation was the module using the Delphi hydrodynamic model, testing reef geometrics under monsoon storm condition. Finally, a 20-year net present value cost benefit analysis compared our natural-based solution approach against conventional hard engineering alternatives. These multi-method issues are reserved both ecologically valid and economically defensible, the two things policymakers need before the commit resource. Now, the result, 4 headline findings. First, 70 to 90% wave height reduction. Our Delphi modeling shows that the oyster reef at 1 meter depth achieve 70 to 90% wave attenuation under typical monsoon storm conditions. This is comparable to a concrete seawall at a fraction of the construction cost. Findings 2. 2 to 4 times increase in sediment accretion rate, the vegetation belt increase sediment deposition 2 to 4 times above baseline. This means the shoreline does not just stop retreating, it begins to relatively actively recover. Our project shoreline established within 3 to 5 years of deployment. Findings 3, third one, and this is our most policy relevant findings. An 8:1 benefit cost ratio for every USD I invested in this natural-based system. Our 20-year NPV analysis shows USD8 in the co-benefit is generated through fisheries enhancement, carbon sequestrations, coastal protections. No concrete structure comes close to the economical return. Findings 4, 2 to 8 tons of carbon sequester per hectare per year, exceeding established mangrove benchmark and opening the door to carbon credit financing, which could make these interventions financial self-sustainable over time. This result does not live only in academic literature. It speaks directly to Bangladesh national and international communication, and it is obligation of every coastal nations in this audience. NAP, Bangladesh National Adaptations. It directly supports priority 3 to Bangladesh National Adaptation Plan, coastal zones protections through ecosystem-based adaptation. Decision makers within the Bangladesh Water Development Board and the Ministry of Environment now have a validated, cost-effective tool available. Now, SDG, it contributes of SDG 13.1, building resilience against climate-related hazard, and to SDG 14.2, the sustainable management of marine and coastal ecosystem. Sendai framework for DRF 2015 to 2030. Under the Sendai framework of disaster risk reduction, these directly address priority 4 build back better after the next major cyclone. Coastal communities can rebuild with bioengineering rather than concrete. Paris Agreement NGC. And the blue carbon component directly strengthens Bangladesh updated nationally determined contributions under the Paris Agreement by quantifying and expanding the country coastal carbon sink at a scale. Let us bring that together. This study demonstrates that the integrated oyster reef and riparian vegetation system is technically feasible, ecological sound, and economically superior to conventions, hard engineering for coastal protections at Bula Island, Bangladesh. The dual system achieved 70 to 90% wave attenuation and 2 to 4 times sand accretions, outperforming concrete benchmark. The 8:1 benefit cost ratio makes the economic argument unanswerable, and the framework is directly replicable across the low-lying deltaic and estuarine coastline of South and Southeast Asia. We are planning a 2 kilometers pilot development at Bula Island in 2026 to 2027 with the long-term monitoring using wave gauges, sediment traps, and oyster density surveys. And we will develop a community co-management framework and produce a policy brief for national level scaling. We will also test replications at our Shirazganj riverine site using freshwater mussel. I will close with this. Natural build Bangladesh coastline over thousands of years. The most sustainable and the most affordable way to protect them is to work with nature, not against it. Natural-based solutions are not a compromise. They are the future of the coastal resilience. Thank you very much for your kind attentions, and I am deeply grateful to be organizing committee of the Climate Change Conference for giving opportunity to present.
You tell us it's feasible, and you put there, you look to the information about 20 years. It's correct what I understand? So basically you have information on 20 years on this issue, and after 20 years of collecting data, your conclusion is it's feasible. This is the correct, what I understand. Yeah.
Yes.
Because
oyster is rebuilt continuously. No need to rebuild again.
yeah, because 20 years, it's a very long time. This is the issue. Normally, when they make study like that, they make 10 years, and 10 years seems to be long. 20 years is very long.
It is likely is proposed framework, not like that is actually do. It's proposed here.
Okay, thank you very much. Very interesting, and thank you for your presentation. We'll go now to the next one. Next one, Sana Azim from Air University, Kamra, Pakistan.
So, good evening, everyone. Thank you so much for having me. My name is Sana Azim, and today I am presenting my study on how the FAO, the Food and Agriculture Organization, talks about the climate change. So I'm here to talk to you about something we usually, as he said while introducing me, that we usually take for granted, the language institutions use when they talk about the climate change. So specifically, I look at how FAO, the UN's Food and Agricultural Organization, talks about agriculture and climate risk, and what I found was pretty surprising. I hope you will enjoy too. So let's get into it. So here's the core motivation. Institutional climate language isn't just describing reality. It's actively deciding who gets framed as vulnerable and what kinds of solutions look reasonable, legitimate. So agencies like FAO and IPCC lean on standardized terms like climate smart agriculture, resilience building, adaptive capacity, terms like this, techno-optimistic kind of terms, which are useful for policy, but they can flatten, like literally flatten the local complexity into generic categories. And surprisingly, very little work has looked closely at what this language does, what a language does at the level of actual word choice and repetition. And that's the gap the study sits in that I am exploring. So here's the starting point for the whole study, that we usually think of climate change as something biophysical, like as a physical problem, like rising temperatures, less rainfall, like that sort of thing. But it's also a discursive problem, meaning the way we talk about the climate change, it actually shapes how we respond to it. And agriculture is especially sensitive to this because it depends so heavily on a stable climate and water availability. And more farming policies being shaped by big global climate frameworks, the IPCC and the FAO and so on. So the question that I wanted to explore is simple, that when these institutions write about climate risk, like climate change, what narrative are they actually telling? What narrative they are building, and what does that story or narrative leave out? So this is the question that is driving the whole research, and I will just read it once, let it sit in. So how are drought, adaptation, and resilience linguistically constructed in FAO institutional texts? And what does that construction reveal about underlying assumptions of human-environment relations? So in really simple terms, what do these words actually do inside institutional writing? And what worldview or ideology do they carry with them? So there's a lot of great research on things like vulnerability, adaptation, resilience. These are the huge topics in climate science. But almost, like, I am not making a huge claim that there is no research at all, but very little research actually looks closely at the language itself, especially in agriculture and aquaculture policy documents. So that's the gap I wanted to fill in. My aim is simply to look specifically at how drought, resilience, and adaptation are talked about in FAO documents, policy documents, and to figure out what does this language tell us about how these institutions actually think about the relationship of humans and in the environment. So for this, I deployed 3 lenses. First is Corpus Assisted Discourse Studies, CADS. Basically using frequency and collocation data, I used AntConc tool that to catch ideology that close reading alone can miss. Secondly, eco-critical linguists has been deployed by Arend Stebe, who talks about how every text tells a kind of a story. Stories we live by. You might have heard this phrase. Story about nature. So some stories are destructive, like treating nature as something to be controlled, something to be managed, like through solutions and through technology. So some, treating nature as something to be controlled, and some are beneficial stories that is treating nature as something to respect and live alongside, co and mutual habitation. And third is the climate vulnerability theory. That's the real tension. And there's a real tension between IPCC's definition of vulnerability, because IPCC is the policy document. They think of vulnerability as something to be, something measurable and outcome based. And then there is more critical tradition that says that vulnerability is something socially and institutionally produced. It's not a fixed rate. It's not, something to be measured or indexed. So I have triangulated all of the 3 theoretical lenses. So what I actually analyze is 2 real FAO documents. The first one is the long report about climate risk in small island developing states. So places like small island nations are extremely vulnerable to drought and rising sea levels. And the second one is a little shorter. It's about teaching farmers in Jordan about climate smart agriculture techniques. But these 2 documents are from FAO. So I want to be clear here that I'm not comparing these 2, because one side is really long and the other one is really not really short, but comparatively it's shorter. But because they are not the same same kind of document on same scale. There are different genres that and that difference is actually part of the finding too. So I ran both through a tool called AntConc, AntConck. It's a linguistic tool. Which let me look at the word frequency and other things like collocation and concordance and KWIC. Like in simple terms, which words consistently appear next to what, or the semantic prosody. So here's the first big finding. Top content words by corpus straight from Bangkok. So corpus is human-centered, like anthropocentric, because farmers is literally the single most frequent content word. Like it's really shocking for me. Right alongside climate and seeds and water, while corpus B looks completely different. There is no, like, I won't say no mention. It does appear, but it appears on rank 52. Like in corpus A, it's appearing on rank number 1. And in corpus B, it's on rank 50. So top content words by corpus straight from the AntConc. Here's the findings. So corpus A is human-centered, like more anthropocentric. Like farmers is literally the single most frequent content word that appears on the top, right alongside with other words like climate, seeds, and water. While corpus B looks completely different. Like there is no form of farmer breaks the top 8 at all, but it does appear on rank number 52. I won't say that it's a complete decentering of humans, but I would rather say that it's just a little, it's not a total erasure, but a little bit decentering. So now here's where it gets more interesting, because I just didn't look at what words appear and in what frequency. I looked at the words which appear next to each other, like the collocations. So in the island report, whenever drought comes, it's almost paired up with the word vulnerability. So like this pairing is so strong. and statistically one of the strongest patterns in the entire study. So what this tells us is that drought isn't treated as a lived experience, but it's treated as something to measure and index a score. Like when resilience comes up, it's almost paired with the word there, as in building resilience for them. Like, you know, like resilience is framed as something outsiders would build for the communities, not something the communities would build for themselves. You know, like waiting for, like the communities are portrayed as victims waiting for the international aids or the funding to cope up with the climate change or their consequences. And now a flip to the other documents, drought barely appears at all, just once, buried in the list, like towards the end of the list. And adaptation is almost linked to mitigation and productivity. So, you know, adaptation, mitigation, productivity, these are very techno-optimistic words. Like it's less about crisis and more about efficiency, like techno-optimistic solutions and things like that. Like something to be dealt with the help of technology and other, you know, procedures. So putting this together using Steve's framework, as I mentioned earlier, that neither of these documents tells what he calls a beneficial story, like about nature. They both tell, both the corpora, they tell what he calls as destructive story, just in totally different ways, of course, not in the same way. The island report, the corpus A, it tells what I call a deficit story. It talks about people, but frames them as helpless or as vulnerable populations who need outside rescue and funding, while the Jordan curriculum tells more of a commodification story. Like it barely acknowledges the crisis at all. Instead it treats farming and by extension nature just as a system, you know, to optimize for productivity. So one corpus is overselling vulnerability, and the other one is basically erasing it totally, you know. So you know, stark contrast. So what's the takeaway here is that institutional language is never neutral. Well, actually, language is never neutral. So the island report quietly frames vulnerable community as passive victims waiting for outside help, and the Jordan curriculum quietly raises the climate risk as it's supposed to be responding to, and replaces it with, you know, with technical and with productivity focused language, and both of these framings avoid the actual truth that the climate vulnerability is often the result of not something physical or biophysical, but of real historical, structural, economical inequality, not just bad luck or the lack of technique. So my argument that if main you know takeaway or argument is that if we want a better climate policy, we also need a better climate language, a language that actually reflects the reality, the structural reality that gives the agency back to these communities that these documents are supposedly about. This is it from my side. And before Q&A, I just wanted to make you clear that I am not saying that these institutional documents or the policy documents have deliberately or intentionally used this kind of vocabulary. All I'm saying is that this is the kind of institutional language, you know, to depoliticize using certain words and certain vocabulary, you know, and create one generic, flatten the complexity and all. So this is it from my side.
Yeah, we understand exactly what you say. Basic, you tell us in the official papers, they invent a new type of semantics. The people are not poor, are less fortunate, something like that. Invent a new word to be more positive, and the situation actually it's more negative. And your kind of observation like that, it's a very interesting for me, like a writer, and also for other people, because we have here a double sense of the words, and you know what it's white and what it's dark. Now it's a gray area.
Yeah, gray area, exactly.
We have a question. Yeah, Mihai. Mihai.
It's more of an sorry, I was tapping the microphone. So it's more of an appreciation. It's like you said, it's a very interesting point of view regarding climate change. And your presentation, Sana, gave me very much food for thought regarding the official language that is used in documents, and I think we all can agree that the language that is used in official documents is varies from country to country and from institution to institution. But to us as researchers, I think it's a very interesting insight. Your paper is a very interesting insight into this problem regarding climate change. So yeah, it was a very positive thing for you to present to us today, and thank you very much for your attendance.
It's truly an honor. I know that the time is really limited, but if you give me just 10 seconds, I would really want to say thank you to you people, because I was having some medical emergency and I couldn't submit my abstract in paper in time, presentation in time, but you gave me some extra extension in date. So it's I'm really honored to present here, to be presenting in front of all the people and different countries, and I'm so glad that you like it. Thank you so much.
Also, we thank you and thank you.
It is my great pleasure to present our research entitled Assessing the Effect of Green Entrepreneurial Orientation on Environmental Performance and Sustainable Development Under Climate Change. This research has been conducted in collaboration with Professor Amina Omran from the Faculty of Economics and Management of Sfax, University of Sfax, and myself, Karima Kasdalla, PhD scholar and research at the same institutions. Our presentation is composed of 5 main parts: an introduction, a literature review, a methodology section, findings and discussion, and finally conclusions and recommendations. Let's start with introduction. Now I will briefly present the historic evolution of sustainable development and corporate social responsibility. From 1970 to 1972, during the awareness stage, the Club of Rome report and the Stockholm Conference marked the first global recognition of environmental issues. Between 1987 and 1992, the stakeholder theory emerged, driven by the Brundtland Report and the Rio Earth Summit, where CSR became a tool for legitimacy and stakeholder engagement. From 2002 to 2015, the institutional framework stage was established particularly through the Johannesburg Summit and the Sustainable Development Goals, introducing measurable sustainability objectives. Finally, in the current stage, CSR has evolved into a strategic competitiveness approach. It is now fully integrated into business model, linking environmental protections with the economic performance. Today, CSR is no longer a symbolic image building practice. It has become a strategic management tool for sustainable competitiveness. Our research focuses on the following question: how does the green entrepreneurial orientation contribute to the achieving environmental sustainable development under the pressures of climate change? Now, let's move in literature review. Climate change has become one of the major challenge facing organizations worldwide. Companies are now ecological pressures, stricter environmental regulations, and growing stakeholder expectations. In this context, firms are required to move beyond traditional economic objectives and develop sustainable strategies that combine competitiveness with environmental responsibility. Therefore, concepts such as green entrepreneurial orientation and corporate social responsibility have gained increasing attention as strategic approaches to addressing climate-related challenges. This research is based on four main concepts. First, green entrepreneurial orientation refers to the strategic orientation of firms toward environmental opportunities through green innovation, proactive environmental actions, and sustainable risk tasking. Second, corporate social responsibility represents the integration of social and environmental concerns into business practices and decision-making processes. Third, environmental performance reflects the ability of firms to reduce negative environmental impact, improve research efficiency, and comply with the environmental requirement. Finally, environmental sustainable development refers to achieving a balance between economic development, environmental protections, and the preservation of resource for future generations. Based on the literature review, we developed our conceptual framework. This framework suggests that the green entrepreneurial orientation represents an important strategic capability that encourages firms to adopt stronger CSR practices. CSR practices then contribute to improving environmental performance by promoting responsible research management and environmental initiatives, ultimately enhancing environmental performance supports the achievement of environmental sustainable development. Now, let's move to the research methodology. This study is based on 250 managers surveyed between February and July 2025. All respondents are decision markers and 72.8% hold a master's degree or higher, with an equal representation of 50% men and 50% women. The firms operate in agriculture, agri-food, manufacturing, energy, ICT, and tourism across northern, central, and southern in Tunisia. The data the data were analyzed using smart PLS4 and the PLS-SIM approach, and the measurement scales showed excellent reliability with the Cronbach's alpha value ranging from 0.882 to 0.951. Now, let's move to findings and discussions. This slide presents the results of the analysis examining the impact of different CSR dimensions and on environmental performance and environmental sustainable development. First, CSR toward employees does not receive empirical support. The relationship with the environmental performance is not significant, with a t-value of 1.746, and the relationship with the environmental sustainable development is also not supported with a t-value of 1.863. In contrast, CSR toward consumers shows the strongest positive effect. This relationship is strongly supported for both environmental performance with a t-value of 11.332 and environmental sustainable development with a t-value of 5.457. Similarly, CSR toward communities has a significant positive impact. The relationship is supported for environmental performance with a t-value of 374, and for environmental sustainable development with a t-value of 3.181. This figure presents the results of our empirical model showing the impact of external CSR practices on environmental outcomes in Tunisian SMEs. The findings indicate that external CSR has a strong explanatory power, accounting for 81.8% of environmental performance variance and 66.2% of environmental sustainable development variance. These results highlight the strategic role of customer engagement. And external stakeholder collaboration in promoting eco-efficiency. In contrast, internal CSR practices do not show a direct significant and effect in this model. Now, conclusions and recommendations. The concept of the triple helix expansion. The main idea is that addressing climate change challenge cannot be achieved by firms acting alone. Sustainable transformation requires a strong collaboration between three key actors: public institutions, academia, and businesses. First, public institutions play a critical role by establishing supportive policies, regulatory frameworks, and incentive mechanisms that encourage green innovation and reduce uncertainty for firms. Second, academic institutions contribute through research, knowledge creation, and technology transfer, helping companies access new scientific and technical solutions. Finally, firms represent the driving force of this transformation by integrating green strategy, sustainable practices, and cleaner production approach into their operation and supply chain. The main contribution of this model is that the collaboration between these three actors creates an ecosystem that supports green innovation, strengthens organizational resilience, and accelerates sustainable development. It shows that sustainability is not only a firm level responsibility, but a collective effort based on cooperation and knowledge share. Finally, I would like to propose a strategic playbook for firms operating in climate-sensitive sectors. This playbook highlights three key actions. First, firms should embed green entrepreneurial orientation at the core of their strategy by investing in research and development and proactive green innovation rather than using CSR as a standalone initiative. Second, they should optimize external CSR practices, particularly through consumer transparency and community partnership, as these actions generate stronger environmental impact. Third, firms need to build absorptive networks with suppliers and academic institutions to acquire and integrate external knowledge, thereby enhancing environmental resilience and accelerating sustainable development. Thank you for your attention.
Thank you very much.
Okay, so again, good evening from the Philippines. I know it's just afternoon in Romania, but here in the Philippines, it's already nighttime. So I'll just be very quick with my presentation. So this study titled Vulnerability of Formosa Queen Pineapple Production in Camarines Norte, Philippines to Sudden Extreme and Slow Onset Events was actually funded by the Westlanders Government of Belgium in Europe through a non-government organization here in the Philippines. The NGO is called Synergy Pilipinas, and our university is called University of Camarines Norte. So this study was done together with my fellow researchers in the University of Camarines Norte. So just to give you a brief rationale, our motivation in conducting this research is the encouragement and the reiteration from the IPCC that we should be trying to understand climate change on a local scale, because most of the studies that we are seeing are actually dealing with climate change on a global scale. So we are encouraged to do climate change studies on a smaller scale, and this time on a provincial scale. Our focus is our province, Camarines Norte. If you can see the map of the Philippines, we are actually located in the Pacific Ocean. We face the Pacific Ocean where most of the tropical cyclones are formed. And our province, the province of Camarines Norte, is in the eastern coast of the country. So we are the first to welcome the typhoons, the tropical cyclones in the Philippines. We experience about 20 tropical cyclones in a year. So we are considered one of the most vulnerable provinces in the Philippines. For the commodity of interest, we chose pineapple. We call it queen pineapple, basically because it's considered as the sweetest pineapple in the world. But if you're going to look at its contribution to the Philippine production of pineapple, it's very small because the big plantations are actually in the southern part of the Philippines. So moving forward, this study aims to assess the areas planted with Formosa queen pineapple as to their vulnerability to the effects of slow onset events, specifically temperature rise and changing rainfall patterns. And we also looked into the biophysical impact and the socioeconomic impact and the adaptive capacity of the farmers. And eventually we wanted to formulate and recommend interventions to reduce vulnerabilities. And I'm happy that I joined this conference because through the presentations that I've listened to, I was patiently waiting for my turn. I actually learned a lot, and I'll be adding them to the recommendations that I have for this study. So just a brief background, just to differentiate sudden, extreme, and slow onset events. When we say sudden extreme events, these are climate hazards which happen very quickly, and hence the effect is extreme. So some examples of sudden extreme events would be tropical cyclones or typhoons and flash floods. And for the slow onset events, these are actually climate hazards that happen gradually, and hence the effect is actually not noticed immediately. It takes a lot of time before you notice the effect. And some examples would be increasing temperature, prolonged drought, and changes in seasonal rainfall patterns. And these are the slow onset events that our study tried focusing on in the province of Camarines Norte. We used the impact chain model. So this is a conceptual model that looked into the hazard, the vulnerability, and the exposure factors that lead to a specifically. So we just don't try to look into how vulnerable a community is, but we also try to look to answer the questions, why are they vulnerable? That's how impact chain models work. For the methodology, we only dealt with 40 pineapple farmers, and because we are actually constrained by budget, so we only dealt with 40 farmers, and these farmers were actually chosen from the two biggest green pineapple producers in the province, San Lorenzo Ruiz and Basud. And in choosing the farmers, we used purposive sampling as our method. We chose those farmers whose main source of living is, of course, pineapple farming, and of course, their willingness to participate in the study. So ethically, we just inform them of the information that we will be gathering and the confidentiality of information, the handling of information in this study. We employed a questionnaire. The questionnaire was quite long. It's a 20-page questionnaire because it consisted of information related to social, demographic, and economic information of the respondents or of the farmers, the farming systems they employ, their vulnerability, and the adaptation strategies they employ relative to the climate hazards, their sensitivity and their awareness, their knowledge, their attitude, and perception relative to climate change. So since it's a long questionnaire and we are actually dealing with farmers, the challenge was actually on their willingness to stay because the interview is typically long. So we use a scheduled approach. We are the ones telling them the questions, and sometimes we need to elaborate on the meaning of the questions, and we are the ones taking note of their responses. Because if you're going to leave the questionnaire to the farmers, chances are you wouldn't get accurate and adequate information. And apart from scheduled approach of gathering information, we also validated the results through a focus group discussion. So now let's proceed with the results. We looked into the exposure of the pineapple farmers and their farming systems to different climate hazards. So one of these climate hazards is the drought. So we actually quantified their exposure from 1 to 5, 1 being very rare and 5 being very frequent. And in terms of drought, pineapple farmers reported very rare exposure to drought. For flooding and heavy rainfall, they reported rare to moderate exposure. And for increasing temperature, which is the slow onset event, they reported very rare to rare level of exposure. And for tropical cyclone, it was actually surprising to know that they only reported rare to moderate exposure, when in fact we actually have a lot of tropical cyclones in our province. Now let's take a look at the biophysical sensitivity, or how the crop and the environment was affected by these hazards. In terms of frequent or prolonged rain, pineapple production system shows very low to low sensitivity. So later we will see how they are specifically affected. And for drought, also very low biophysical sensitivity. For flooding, very low sensitivity, indicating that pineapple is actually a flood-resistant crop. And that's why a lot of farmers in our province are actually preferring this crop over other crops like vegetables. So for increasing temperature, in terms of biophysical sensitivity, the sensitivity is also very low. For tropical cyclone, they also said that they have very low sensitivity to tropical cyclone. So let's take a look at how the crops are affected by these climate hazards. For increasing temperature, they have observed that fruiting of the pineapple is actually delayed. Fruiting of pineapple, the life of pineapple crop usually takes up to 18 months. So it's a long, it takes a lot of time growing this crop. And with increasing temperature, for those who have observed increasing temperature to be a hazard, they have observed that fruiting of their pineapple is delayed. And apart from delaying the fruiting of the pineapple, the fruit size and the weight are actually reduced. And that's why they get a lot of pineapples that are below the marketable size. And apart from smaller, they are also uneven in shapes and in terms of the number of suckers, because pineapple is propagated through suckers. So the number of suckers or new planting materials that is produced during the growing season is also reduced because of increasing temperature. In terms of heavy rainfall events, what they have observed is that they have very low biophysical sensitivity here because most of them are actually planting pineapple crops in hilly terrains. That's why the flood water easily gets drained. So flooding and heavy rainfall is not really much of a problem. But for those pineapple farmers who experience this, they experience reduced production and, of course, yield. So for frequent or prolonged drain, so this is not really flooding, but frequent or prolonged drain, it causes waterlogging. So there's no flooding, but the soil is already wet. The subsoil is already wet. So they experience reduced pineapple growth, and instead of getting 18 months, sometimes it is prolonged. I mean, the growth of the pineapple is prolonged, and that eventually that yield to reduced fruit weight and yield. And in terms of prolonged dry season or drought, their biophysical sensitivity is also very low. They observed wilting of pineapple leaves, reduced flowering, prolonged growth period. So those are the observations they have for their pineapples when they encounter drought. For tropical cyclone, they basically experience crop damage due to strong winds and heavy rains. Now, for the socioeconomic sensitivity, you can see here that most of the farmers also reported very low to low sensitivity, whether for drought, for prolonged drain, for increasing temperature. The only high socioeconomic sensitivity they have was for tropical cyclone, and that was about low to moderate sensitivity. So now let's take a look at how they are affected socioeconomically. So socioeconomically, most of them have reported, of course, reduced sales due to the reduction in yield that I reported earlier, and also reduced income for the family. So that is for temperature increase and for flooding and heavy rains as well. For frequent or prolonged rain, they've also complained about prolonged waiting for harvest, basically because the growing season has been extended because of frequent or prolonged rain. So they had to wait longer. Imagine waiting for 18 months and prolonging that sometimes to 20 to 24 because of frequent or prolonged rain. And then frequent or prolonged dry season or drought, the same effect with prolonged drain, prolonged waiting for harvest, and of course, reduction in sales as well. For tropical cyclones, reduction in yield and income, basically the damage is higher for tropical cyclone because of the combination of strong winds and rain. Now, we also looked into the adaptive capacity of our pineapple farmers. We looked into the availability of household labor. According to them, they have moderate level of labor availability. We also looked into their general knowledge on climate hazards, which they reported to be moderate to high. Unfortunately, their awareness is only on a general level, not on a profound level of understanding as far as what climate change is. And level of resource availability in terms of farm to market roads, internet signal, mobile signal. Most of our farms in the province can actually be reached by this communication signal, by these telecommunication signals, and also by farm to market roads. That's why they reported the resource availability to be high. In terms of early warning systems, they don't have much technological advancement as far as early warning system is concerned. But what they appreciate about are the barangay disaster risk reduction and management personnel who are the ones roaming from one house to another whenever there is a disaster to come. Like, for example, if there's a typhoon to come, and households have to evacuate, there will be disaster risk reduction and management personnel from the barangay who would remind everybody to evacuate or to abandon their houses. And then access to community support systems. The good thing is there are a lot of farmers associations where they can join in, either in their barangays or in their neighboring barangays. But there are still some farmers who do not join these farmers associations, and hence, as a result, they cannot avail of the government aid that's usually given to farmers associations instead of individual farmers. And then for wealth level of their communities, based on their perception, their communities are generally moderately rich. And for the adaptation measures, their adaptation measures are still very minimal. In terms of temperature increase, what they were telling us is that they just plant trees. They plant trees around their farms, and that for them is enough to somehow minimize the impact of increasing temperature. But in terms of technological adaptation, they don't have much knowledge yet on specific technological adaptations that we can use for temperature increase. And for heavy rainfall, again, no specific technological adaptation as well. What they do is they just plant in hilly areas so that flooding will not be an issue. For frequent or prolonged rain, again, no specific technological adaptation measures, as well as for drought. So generally, they do not have technological adaptation measures in their community. We also tried to calculate the vulnerability of the pineapple farmers. And as you can see here, it's color-coded based on, actually, the colored barangays are the ones which are planting pineapple on a large scale. That's why they were the ones chosen for this study. So most of the barangays are highly vulnerable or moderately vulnerable to tropical cyclones. But in terms of slow onset events like increasing temperature and changing rainfall patterns, as you can see, most of them are still green to light green. So indicating that their vulnerability is still manageable or still low. So these are some additional conclusions that we have found in the study. In the interest of time, I just want to highlight that in terms of the profile of the farmers, most of the farmers are in their middle age to elderly farmers, like 40, and surprisingly, there are still farmers who are 80 years old and beyond in the Philippines. Educational attainment is generally low. That's why their capacity to take in information that they can use to adapt with the changing climate is also quite low. And then farms are generally small, 1 to 2 hectares. And then earnings or income remain generally low, basically because most of the farmers are dependent in just one crop. They do not diversify. They do not have other sources of income. Or if they have, it's generally very minimal and not enough to augment the financial needs of their households. And despite their long-term residency in their communities, their organizational participation is still low. And farmers in Camarines Norte consistently report clear and intensifying signs of climate change characterized by stronger and more frequent tropical cyclones, extreme rainfall events, rising temperature, and prolonged dry spell. So pineapple consistently exhibited very low to low sensitivity to both flood and drought, indicating greater tolerance to both moisture excess and deficit. That's why this is the preferred crop of farmers in the province instead of vegetables, which is highly vulnerable to changing climate. So adjusting the timing of planting and harvesting is actually the most popular adaptation strategy that they have. So they are just changing their calendar, but sometimes they get confused with all this changing climates that's happening in our province. Now, We are at a stage in our research where we try to recommend policies to our local government units here in the province. So some of our recommendations, I mean, we've actually prepared policy briefs and we're trying to communicate these recommendations to them. Some of them would be to capacitate and support our farmers in off-farm enterprise so that they will rely less on agriculture enterprise as their souls will actually improve their socioeconomic resilience. And then funding for the implementation of quality water impounding projects to increase the farming community's adaptive capacity to climate hazards. So maybe you are thinking that at this point, their vulnerabilities is still very low, but considering the predictions in terms of flooding, in terms of heavy rainfall, in terms of rising temperature, we really need to be ready. And recently, the Philippine government is plagued with issues involving flood control projects in the form of dikes. So in this policy briefs that we are trying to develop, that we have developed, we are actually recommending water impounding projects instead of dikes. So water impounding projects which would temporarily store rainwater and eventually use them during periods of prolonged drought. And of course, enhance farmers' decision-making through climate information services. So we have to inform our farmers about how weather and how climate is changing so that their cropping calendar would be updated and they would be guided in terms of their decisions. And then provide climate literacy training for farmers, although they have good general knowledge and they generally believe that climate change is happening, they do not understand it in a more profound level yet. And capacitate farmers on on-farm level adaptive practices and soil water management like sustainable agriculture and organic farming. And of course, strengthen the community-based support systems and early warning mechanisms in our province. So these are some of the recommendations that we have indicated in the policy briefs that we have developed. So thank you very much for your time.
Thank you. Stop the sharing to can see together and to can discuss. Okay, you stop the sharing. So I like the approach you told us. If it's dry, plant 3 pineapple. If it's raining, plant 3 pineapple. If it's flooding, plant 3 pineapple. So to all this, you have only one issue: more pineapple tree. And this is very nice because actually work.
Because the pineapple grows for 18 months at the very least. That's why they really have no choice but to plant pineapple. What they are lacking are actually strategies on how to make their pineapple more ready with the changing climate that's going to be happening in the years to come.
If there are other questions, because I saw, two. First, Ionuț, yeah.
Hello, Roger. Congratulations for your presentation.
Hello, sir.
And for your patience to stay with us all the conference. In your conclusion, you are right about young people do not want to be involved to the agriculture. Why? What is the reason? Why do not involved? What's happening?
Actually, that's a very complex issue because apart from the fact that agriculture has become a less attractive enterprise, less attractive career to young people, even in their households, like for example, their parents would normally tell them that, son, daughter, you have to study very hard because I don't want you to be like me, just a farmer. So they have that inferiority complex being farmers because out here in the Philippines, farmers do not generally earn a lot. So they remain to be the poorest among the sectors in the Philippines, and they remain to be the least educated sector of the country. That's why they have that inferiority complex, not realizing that we actually need more of them. It's just a matter of encouraging our young people to study agriculture, to make their agriculture more scientific rather than rather than the way they did it before, rather than the way their ancestors has done agriculture in the past. So my point is, even in the family, the young people are actually discouraged by the parents themselves. Second would be in our what you call that, in our job market. Usually, agriculture related professionals are not typically looked as an attractive career venture for among young people. That's why most of the universities here, if you're going to look at their enrollment, agriculture related or subscription to agriculture related courses is dwindling down. That's why earlier during the presentation of our colleague from Saudi Arabia or Dubai, the climate memory
Saudi
fund.
Arabia.
I think
Arabia Saudi,
Saudi Arabia.
Mhm.
I think that's actually one way of drawing back our youth to engage in agriculture by applying AI, by applying machine learning, by applying digital technology. I think our young people will realize that there's more to do in agriculture rather than the traditional planting, rather than the traditional way of doing agriculture. So they have a huge role to play in making our agriculture sector sustainable.
Okay, I have another question from other colleague behind.
Thank you, Roger.
Roger, congrats on your presentation, and thank you again for your patience. First of all, I would like to thank you because your presentation, according to your study, just planted the seed in my head for me and to start a pineapple plantation in Bujoru. I don't know if it's feasible. We have vines to make wine, but I don't think that the farmers that you interviewed, I think I don't know if they were truly honest with you, because you said that the fruit size of the pineapple, the size of the pineapple was smaller. So I think there are some physical chemicals imbalances there, because the high temperatures tend to accumulate more sugar in the fruit. That's a good and also a bad thing, because when the chemical imbalances happen, the fruits aren't as pleasurable to the consumers, as they have a certain standard. And another thing, at the end of the presentation, you said, and you mentioned this, that the pineapples are grown on hills, and the farmers are very happy that they don't have the problems with the excess of water when the extreme climate phenomena happens. But as specialists here, I think we need to keep in mind that runoffs, when heavy rain is falling, tend to make imbalances in the soil structures, like nitrogen, organic carbon washes away with the heavy rainfall. So I think that just as a recommendation, maybe you have a whole team behind you to maybe start, implementing some educational programs to the farmers, to let them, here in Romania, we have a spontaneous flora growing in the vines, and then we use that as support for enhancing the organic carbon ratio, So I don't know if this can be applied to the Philippines and in the pineapple farms, but I think it's worth a shot. The study is very interesting, and I'm glad that the pineapple. I'm a fan of pineapple. It goes to it's used in cakes, and we eat it as is, and also in cocktails because it's summer, and I love it very much. But I think that maybe the most important aspect of your study, which is very good. Maybe you can extend it, your team can extend it to in regards to educating the farmers, and also the same thing about the acceptance of the students in agriculture is also here present in Romania. Not very much young people are drawn towards this to be a specialist as a agronomist in agronomy, but thanks to Agriculture 5.0 that uses technology, maybe we can also attract young people because they are passionate about technology. So they need to understand that some practices can be, can use technology, and maybe we can attract them to this domain of practices. So yeah. I hope this is useful for you. So just
Thank you
think
very
about
much,
it.
sir. Actually, I agree with you. One of the limitations of our study, which I actually mentioned in our full paper currently under review in a journal, is the cognitive bias among the farmers. So sometimes they oversimplify their responses and they just recall on the feet of memory. So they probably do not look into the details of the things that you were saying, like runoff, soil erosion. So we will actually include that in our future studies. Soil erosion is also a slow onset event. Unfortunately, we were not able to capture it anymore, but in future studies, that's definitely worth looking into. Thank you very much, sir, for your suggestion. I appreciate it.
Yeah, great.
Thank you. Okay, also thank you. And we will go to the poster section.
Everybody, I want to share my screen. I don't know if it's work. Okay,
Good.
thank you. My name is Agnieszka Napierkowska-Krzebiecka. I worked in National Inland Fisheries Research Institute in Olsztyn in Poland, and I want to present some results on the title Mitigating the Negative Effects of Climate Change in the Agro-Hydro System for Sustainable Agriculture and Aquaculture. This topic is of interest for people who realize the project called Path4Med, which is on demonstrating innovative pathways addressing water pollution in the Mediterranean agro-hydro system, but also it concerns on other European countries and regions. The effects of climate change is visible on agriculture and aquaculture, and it is a special concern in Poland, but also in the for whole European countries. In Poland, the agriculture sector, including aquaculture, plays a very significant role in economy and exerts pressure on the quality of surface waters and also on of groundwaters. Poland is one of the countries with relatively limited water resources, with renewable freshwater resources which range from 1,100 to 1,600 cubic meters per capita. Poland is as the third country among European countries with the lowest amount of fresh water per capita, just after Cyprus and Malta. Poland is also considered as one of the European countries particularly vulnerable to water shortages. Therefore, the need to protect both the waters, groundwater and surface waters, is the main and priority goals for ensuring good quantity and good quality of waters in Poland. This is aligned with the objectives which are realized within Platform-Med project. This project is realized by 26 partners and demonstrate innovative pathways for addressing water pollution in the Mediterranean agrohydro system and in the other regions of Europe. The aims of the studies focused on describing water quantity and water quality, and in Poland as an example of the country in the Baltic Sea region, and in other European countries, to assess the nitrogen loads from livestock production, and to propose possible innovative nature-based solution to mitigate the effects of climate change, which is visible in agriculture and aquaculture. The methods for this research concern the literature review and the selected articles and documents, and also own data as a part of Platform-Med project. This project includes 4 main goals: zero pollution solutions, policy integration, innovative monitoring, and community empowerment. As a result, we confirmed that the large proportion of surface waters failed to achieve a good ecological status. In Europe, on average, it is over 60%, while in Poland, 67% of all water bodies which were studied. A similar trend was also observed concerning the chemical monitoring of water bodies, and a good chemical status was not achieved by 68% of all river bodies and 78% of lake bodies which were studied. Groundwater is less polluted than surface waters, and a good quantitative status was recorded in over 90%, and good chemical status in over 70% of groundwaters. The figures 2 and 3 present some situation in all European countries which had the information about quantitative status of groundwaters and data on status of waters. In the agrohydro system, the main focus was on the amount of nitrogen released into the environment from agriculture. This is the main pollutant for Polish waters. It was confirmed that in 2020, the upper permissible limit of 170 kilograms per hectare was exceeded in some Polish parts which were studied. Therefore, the detailed information was published in the cited literature in this poster. And due to such situation, the innovative nature-based solution should be used to mitigate climate change in aquaculture and agriculture. And we confirm that the most common solution should be the use of nature vegetation buffer zones to reduce nutrient export and protect against eutrophication. Also, the use of treatment wetlands to control livestock manure and mitigate the pollution, and also the use of small retention to mitigate especially the droughts. For example, we want to show that the carp ponds are an important tool in Polish aquaculture, not only for fish production, but also for water retention, management, and preventing the negative effects of drought related to climate change. We concluded that the water problem is not only in Poland, but also is Europe-wide, and this problem is involved in European Union's common agricultural policy. This policy promotes actions of education, especially of education and advisory activities for farmers, control activities regarding the use of pesticides or fertilizers, the action to improve agricultural practices. These all actions aim to provide the safe food and other biomass, support biodiversity, store and regulate the flow of water, and mitigate the effects of climate change. Therefore, these activities, which were incorporated within Performed project, also show the aspects advancing sustainable agriculture and safeguarding the health of soils, of waters, including aquatic organisms, but also of human health. Thank you.
Thank you very much. You can stop the sharing. I saw some level of information you put there. So it's 1,100 cube per capita. That means it's very low.
Yes, 1,100 when we have a drought season, and 1,600.
So basically the Poland start to have problem with water.
Yes, it is. This data come from statistics in 2025, and it's
so probably now it's worst today.
Maybe yes.
Yeah. Okay. Because for me this level was shockingly low. Because in Romania we have 2,000 and over 2,000 per capita, but we have mountain, we have a lot of river, and this is the big difference, because you can keep the water, but the discussion is about quality of water, not the volume of water. Here, you already have this issue of also of the volume of water, that it's worst like discussion in our country. So this, I think, will be the problem of all European Union in the future, because with this climate change, the water start to become a very important issue. And also I saw the map you put, and for me it was shocking to see how polluted are Finland, for example, who are full of water, and everything there was red.
Yes.
In your
Sweden. It's in Sweden, Red.
Oh, Sweden. Sorry,
Yeah.
Sweden. So this is but they have a lot of water, but not good quality. This is the big problem in this area.
Yeah, but in Romania, it's
Green, full green.
it's for 100% in good water quantity, and quality of only below 10%.
Yeah, it's around 8% who are not okay, but especially in some industrial area, it's the same issue like in Poland. They drop a lot of ugly stuff in the communist era, and now we start to recover the stupid thing from the past. This was common in all this country. So thank you very much for your presence and for passion to stay so long with us, because it was very long. And I hope to in the future to have some common project, because also our institute is in agriculture, so probably we can get common ground on some issue in the future. I will send you your email to my colleagues and we'll contact you in the future. Thank you again to be present to our conference. And we will go to the last one, but not the end. A poster from Romania, Alina Nicoleta Macoveiu Dobre.
My name is Alina Nicoleta Dobre. I'm to present our review, but I don't see my poster.
We have some technical problem. We'll be in a second.
Yeah. Let's start. Imagine a resource that can help capture carbon dioxide, restore marine ecosystem, provide sustainable food and energy, and at the same time create significant economic value. This resource already exists, and it's found in our seas and ocean, seaweed. It's the marine macroalgae. The climate change is one of the greatest global challenge, driving rising temperature, ocean acidification, biodiversity loss, and increasing pressure on food production system. In this context, seaweed have emerged as an effective and sustainable nature-based solution, because they simultaneously contribute to climate mitigation, environmental restoration, and the development of the blue bioeconomy. If you can see, there are four main pathways through which seaweeds contribute to climate action. First, the carbon capture, where Sweden fixes atmospheric dioxide carbon into their biomass. Second, nutrient removal, reducing eutrophication and improving coastal water quality. Fourth, they help reduce ocean acidification by increasing local pH and oxygen availability, creating healthier environments for marine organisms. And finally, seaweeds represent renewable biomass resource, providing sustainable raw materials for food, feed, biofuel, bioplastic, pharmaceutical, cosmetic, and agriculture. An important aspect of this review is the comparison of carbon sequestration among the different marine ecosystems. As is illustrated in this graph, seaweed meadow have the highest carbon sequestration potential, approximately 219 tons of carbon per square kilometer per year. For comparison, salt marsh store around 120 tons carbon, mangrove 150 tons carbon, seagrass about 200 ton carbon per square kilometer per year. Therefore, seaweed's ecosystem can store up to 50% more carbon than other major coastal blue carbon ecosystem, highlighting their exceptional role in the climate mitigation. The Sweden industry has experienced a remarkable growth. Global production increased from approximately 10.5 million tons and 200 to an estimate 43 million tons in 2025, representing more than a fourfold increase. Asia dominate this sector, accounting for 94% of global production. China is the leader of producer with 65% of worldwide production, followed by Indonesia with around 70%. Economically, the global Sweden market is expected to reach approximately $18 billion by 2025, with an annual growth rate of 6-7%. This expansion is driven by increasing demand for the food industry, animal feed, bioenergy, pharmaceutical, cosmetic, fertilizer, and biodegradable materials. Seaweeds have numerous commercial applications that are used as nutrition, food rich in vitamin, minerals, protein, and bioactive compound. In agriculture, they serve as feed ingredients that improve animal health and reduce environmental impact. Seaweeds are also promising feedstock for biofuel and biodegradable plastic, offering a sustainable alternative to fossil-based products. Furthermore, they are widely applied in pharmaceutical, cosmetic, agriculture, wastewater treatment, and environmental remediation. Sweden directly supports several United Nations Sustainable Development Goals. They contribute to zero hunger through sustainable food production, climate action by reducing carbon emission, life below water through ecosystem restoration, responsible consumption and production via renewable biomass, and affordable and clean energy through biofuel production. The future perspective looking ahead, expanding Sweden cultivation require continued technological innovation, supporting public policy, international collaboration, and improving carbon accounting methodology. Further research should focus on optimizing cultivation system, increasing productivity, developing high-value product, and integrating seaweed farming into circular blue economy strategy. In the conclusion, seaweed represent a powerful nature-based solution for addressing climate change. They combine carbon capture, ecosystem restoration, and sustainable biomass production in a single resource. Their application extend across food, feed, energy, and high-value bioproducts, supporting both climate mitigation and adaptation efforts. Our key message is simple. By harnessing the potential of seaweed today, you can help build a more sustainable, resilient, and climate-friendly future for generations to come. Thank you very much for attention.
Stop sharing. Thank you very much. And with this poster presentation, we will end the climate change conference. We'll be online on ICDEAPA YouTube. Thank you all and good day.